confirm or whatever on their website.
Oh, even with restream?
Seems like it.
That's kind of annoying.
Yeah.
That's almost like a
step before.
no go.
Yeah. Yeah, exactly, dude. That's why I dropped Rock Band. I was like, I'm not doing this every time.
Yeah. At least with kick seems kind of useless, but at least I don't have to touch it.
Right. Exactly. Oh wait, well this time it actually just worked. So we're good. All right, let me play my intro real quick and we'll just kick it off.
Sounds good.
All right, cool. Intro's over. Yo, what's up, Wizard? What's up, Chris? What's up, Toby? Shout out to everyone in the chat who's joining us. Today we were gonna have a nuclear physicist on, but he got called into work, had to go into work, so he's not able to make it today. Fortunately, we do have some other topics to discuss. A hot topic right now is Wang, linear motion and special relativity, and the implications of C plus V versus a world where distance and time capitulate to the constancy of the speed of light. So we're going to get into an interferometry experiment here that falsifies special relativity. And it explicitly works off of deriving velocity using using fluctuations in the speed of light, a fringe shift pattern caused by the fluctuation in the speed of light. And then we're going to look at some patented technology based on that. So we're gonna examine the claims of being able to detect linear motion with interferometry, and then we're going to get into GPS. We're going to get into atomic clock synchronization versus Einstein synchronization. And we're going to answer the age-old mystery, how do you cook the books? Well, if you were sending electromagnetic propagations across meridians, there may or may not be an artificial correction that exists that will artificially change the distances to capitulate to a globular coordinate system. So we're going to read all these documents in great detail and put it under the microscope. This might be a long episode, but this will be very educational, to say the least. All right. Toby, anything you would like to add, sir?
No, well said. Sounds good.
All right, cool. What's up? We're gonna get into it. We'll start with Wang, and we'll just read into it.
Oh, okay. It's a tender subject in my brain right now.
Yeah, well, it should be a very fresh subject as we just covered it in great detail. But this is to, go over it in detail again. So
yeah, just to give a quick background on that, about an hour or two ago, me and Alan went onto I Can Science That's channel, and he had put out what he called kind of like a I don't know if you would call it a refutation to Wang's 2004 experiment. And so me and Alan were basically coming to respond to that refutation, making our position clear, and that the classical interpretation shows a C plus V, C minus V relationship with speaking of the velocity of light.
Yeah, and that interference pattern that's created from that, with that difference, is used in technology for for inertial navigation systems, etc. Like, this is a real phenomenon. This is a real thing. But we're getting into the intricacies of how it actually works and the original interpretations of how it worked versus the relativistic paradigm, which says that this type of motion that it detects shouldn't even be detectable, right? So these are huge issues. Master stream volume seems to be at 50%. Not sure. Let me see. Let me move my mic closer. Does that sound better? Does my mic sound clearer?
And it sounded okay on my end. I don't know if they're trying to say there's something up with your stream, maybe.
Yeah, you sound good, Alan.
Okay, cool. Yeah, I'm not sure, Riggs. Sorry about that. Okay, so this is the generalized sagnac effect. So quick history on the sagnac effect.
Oh, you're not sure with Discord.
Oh, yeah, good idea. Good call. Thank you. Okay, cool. So we'll get into right here. So this is the generalized sagnac effect. So in In 1905, special relativity came out, and two postulates were put forward. One, that all inertial frames are equally valid, and two, that the speed of light is constant in all inertial reference frames, irrespective of the velocity of the source or observer. So, with those postulates put forward, a mathematical framework is used that involves something called the Lorentz symmetry, which we'll get into a little later. But that framework was put forward to explain linear interferometry, or what they call linear interferometry, for the Michelson-Morley experiment. And they say that experiment cannot measure linear motion, and that the speed of light is the same. So that was like the experimental interpretation of that for the jumping off point for special relativity, because they didn't get a fringe shift pattern that corresponded to how much velocity they would have needed if the Earth was in motion, right? So the framework moving forward from 1905 was that the speed of light is constant and all inertial reference frames are equally valid. Okay, so and Einstein defines explicitly an inertial reference frame, like the stationary, at rest, right? Like in the Newtonian sense. But he also defined any closed polygonal circuit in uniform rotation as an inertial frame. So if you looked at that like a plane flying around the equator at a constant velocity and altitude, that orbital loop, that would be an inertial frame, right? That would be equivalent to being stationary in Einstein's own words in his 1905 paper. Pull up his paper, search polygonal. It should be the first one that comes up, and you could read it from his example, right? So that was 1905. 1913, Sagnac comes in with a circular interferometer, and we'll take a look at a circular interferometer really quickly. Oops, it's the wrong one. Where's my foreign printer? Circular interferometer. Okay, so the circular interferometer here is you have your light source and your photographic recorder on a platform. you have a triangle, circular, whatever configuration here on the mirror setup. This one, so basically the path of light just travels along the mirrors, and then it's recombined from the source. It's split. Okay, let me back up. From the source, the beam hits a beam splitter. It goes in opposite directions. It's then, after hitting mirrors, it's then recombined, and then it hits a photographic plate. The interference pattern from between the two produces the reading, right? So this is the original configuration, and when you rotate the device in a uniform motion, it produces a fringe, right? So this is an inertial frame. So the observer being on the rotating device is considered an inertial frame by Einstein's definitions, right? This is a closed polygonal loop in uniform rotation by his definition. So in 1913, Sagnac says he falsified special relativity. In what's it called? Okay, so and then from 1913 to 1917, this goes completely unanswered by the relativist. It isn't until 1917 someone comes up with a explanation for it. Now they have to use a coordinate system where they transform to the center of the device for the preferred coordinate system to derive the variance in special relativity. Now that answer wasn't really sufficient because, let's be honest, it's falsified on the face of it right there, right? If you have to transform and move to a different theoretical location to explain the effect in reality, like, you just got GG'd, right? So Paul Lavue steps in to say, hey, well, we can use general relativity to actually answer it, but they do the same thing. They transform to the center, but they say that, so they, first of all, they declassify the uniformly rotating disk as an inertial frame. They say, no, special relativity doesn't apply. You have to use general relativity. General relativity puts the observer in the center as well for quote unquote mathematical convenience. And then they say that the energy of the rotating device is equivalent to a gravitational field that generates links of time dilation and length contraction. So that's how they explain it mathematically in their effect, always placing the observer in the center, right? So the classic interpretation for the Sagnac effect, obviously, is C plus V. So that's a direct refutation to the constancy of the speed of light. So here we are now. We're looking at the generalized Sagnac effect. So that was just to catch up on the history. Give me 1 second. I have to get some water.
Cool. Yo, Clearview, welcome. Looks like we small crew tonight, although you know what? Usually always starts as a small crew.
Yeah, it's still pretty early on the West Coast over here, so give it time. More will pour in.
All right, cool. So I'm back now. So we're at the generalized sagnac effect now. So we're going to read about this technology and see what happens. This is a fiber optic gyro. So this is a just basically it's a cable that's wound in a spool, and that's it. And this guy does some experiments unwinding the spool and doing some different configurations. And we're going to see what type of motion he's able to measure with a what's generally associated with a the Sagnac effect. So experiments were conducted to study light propagation in a light guide loop consisting of linear and circularly moving segments. We found that any segment of the loop contributes to the total phase difference between the counterpropagating light beams in the loop. The contribution is proportional to the product of the moving velocity v and the projection of the segment length delta L on the moving direction. Delta phi equals 4 pi v delta L over c lambda. So this is the equations that they're using for this. 1 second. It is independent of the type of motion and the refractive index of the waveguides. The finding includes the Sagnac effect of rotation as a special case and suggests a new fiber optic sensor for measuring linear motion with nanoscale sensitivity. So remember, in fiber optic gyros and ring laser gyros and all that, there's no such thing as you can't measure linear motion, right? It would have to be relative to something. You would need external input. Otherwise, the Michelson-Morley experiment would have revealed the velocity of Earth, right? Based on its orientation. Okay. So, any questions so far?
Nope.
Cool. All right. The Sagnac effect shows that two counter-propagating light beams take different time intervals to travel a closed path on a rotating disk, while the light source and detector are rotating with the disk. When the disk rotates clockwise, a propagating clockwise beam takes a longer time interval than a beam propagating clockwise. While both of the time travel is the same path in the opposite directions, the time travel difference between them is delta t equals 4a omega over c squared, where a is the enclosed area and omega is the angular velocity of the rotation. Since the 1970s, the Sagnac effect has found a critical application in navigation as the fundamental design principle for fiber optic gyros. In a fiber optic gyro, a single mode fiber is wound into a circular coil N, with the amount of N turns. The Sagnac effect is enhanced by N times, so that the time travel difference is 2v NL over c squared, where v is the velocity of the rotating fiber, and L is the circumference of the circle, and NL is the total length of the fiber. The time difference in the fiber optic gyro can be expressed with the equation delta phi 2 pi delta tc over lambda, where lambda is the free wavelength or the free space wavelength of light today. The free space wavelength of light. Today, fiber optic gyros become highly sensitive detectors for measuring rotational motion and navigation. So, to this day, they're like, okay, to this day, it's only rotational effects, right? There's no linear motion. Who's that? Never met her, right?
Yep.
It is believed that the Sagnac effect exists only in circular motion. However, we have discovered that any moving path contributes to the total phase difference between counter-propagating beams in the loop. The previous experiment using a fiber optic conveyor, an FOC, we showed our preliminary results that a segment of linearly moving glass fiber contributes delta phi equals 4 pi VL over C lambda to the phase difference. Here, we generalize our finding for the sagnac effect with a more complete study of and a series of new experiments. Our experiments include different types of motion and light paths with a glass fiber and an air core. In a study, we found that the waveguide loop consisting of linearly and circular moving segments, any segment of the loop contributes to the phase difference of the counter propagating beams. Let me put up the
So a quick,
yeah, go ahead.
go ahead and do what you're going to do. But also a quick point on that. Um, my understanding is the reason to do it with air core and with glass fiber is basically to address. It seemed like for a minute, or just to address the idea that there's some kind of particular refraction rate that's occurring with the motion. Like that, if you get the same relative difference regardless of your refractive index, right, then you're showing that the motion itself it's a more direct relationship of the motion affecting the fringe shift versus you can't claim there's some kind of phenomena happening with due to refraction.
Yeah, it looks like they're trying to rule out any other cause other than the motion.
Yep.
Yeah, and that makes sense by using the two different types of lines, right? It
Yeah.
eliminates that possibility.
Yep.
Yep.
And we can keep in mind, so quick, Toby, if you want to run down the patent history real quick in between these experiments, before we get into it, just to give context.
Yeah, 2003, Wang and crew, they did experiments kind of similar to this, showing linear motion, attributing to the fringe shift in the sagnac effect. They used a series of different fiber conveyor setups. So he kind of already knew it from that the linear motion was contributing to the fringe. So that was in 2003. In January of 2004, he filed the preliminary work for a patent for a speedometer that measures absolute motion using the fringe shift of these linear of a linear interferometer setup. And so he did that in January 2004, and then later in 2004, he got set up to do this experiment. And don't forget, this uses, multi-million-dollar gyros, lots of very fancy air core fiber and glass core fiber, and this all funded through the military. So he saw what it was. He filed for the speedometer, and then he did more experiments to show that it's occurring. So that all happened back in 2004. 2009, the patent was approved. He's patented with his speedometer. And here we are now, what is this, like 2009, 2004 so it's been almost 20 years. And he is still, a few years ago, he wrote another paper showing more possible configurations you could do to further debunk relativity or at least cause problems for how they're going to have to ad hoc explain that. And he showed a bunch more configurations of this. They're all just theoretical. But like the idea being that he's been thinking about it since. He clearly proved it to himself and through his experimentation. And that's why he filed the patent. That's why he got the patent. That's why he's still writing about it 19 years later. And then he even wrote a paper this January, specifically talking about the direction, the speed of light being different in different directions. So he's to say his 2004 paper was some kind of unremarkable experiment or some kind of parlor trick or something, then why is he still so obsessed with it? Why did he get a patent based on it? Why was the government or why was the military interested? Why is, there's a lot of whys you have to ask. Like, if this is unremarkable, then we're missing something here, because all the signs show to him, showing to himself and to the world that this was indeed remarkable and functional as far as using for a speedometer.
And just to be clear, Toby, wouldn't you say that the most remarkable aspect of it was that linear velocity had been attempted to be measured before, which was known as the Michelson-Morley experiment, and then that's the whole reason why relativity was proposed in the first place, because it claimed to have failed to be able to measure linear velocity at all. So that would make this a remarkable experiment if he was using laser interferometry to measure linear velocity. Is that a kind of an accurate assessment?
Yeah, absolutely. And it's difficult because there's so many assertions that were made and just assumed to be true, that we're disproving these assertions that were just assumed to be true. And because these things have been assumed to be true for so long, and there's been so many other scientific assumptions that have been made on top of that assertion, that it's there's a lot of cognitive dissonance for people to try and broach this. That's why you would say that this was a parlor trick. That's why you would say someone was messing around. That's why, this is, this means the Earth's not in motion, really. It's dead straight up. That's what this means. The Earth's not in motion, or the Earth is moving at a rate that's like a small drift akin to the rate of the ether wind, right? Like, because we can't really make an assertion about relative motion, especially until we can start moving our own interferometry readings up and down on the z-axis. But like, but yeah, to try and make any other assertion about, I mean, the only other route you could maybe go is that if you're trying to say we're not geostationary, you could maybe say, if you could somehow prove the relative motion to be one way or the other, you could maybe say, oh, well, we're kind of geocentric. We have like a slow drift, like our overall motion somehow equates out to just be a slow rotation, like a slow drift. But, like, it's not at all related to the relative speed of the cosmos that we witness. So it's not like a true rotation as we witness it. Like everything is moving at this crazy shape in which we only actually move a small amount through absolute space. Because really that's what this is kind of getting at, is this idea of absolute space, right? Where we are detecting differences in the speed of light over what I would call the idea of absolute space, or what we would call ether.
Yeah, and regardless of whether like Wang, whatever he claims to think about the validity of Einsteinian relativity, wouldn't you also say that the fact that he immediately went to go file a patent just kind of shows through his actions?
Exactly. Yeah. Like he wasn't just shrugging his shoulders like, "Oh, that was a fun parlor trick."
Yeah, he was looking to profit off of this for sure.
Yeah.
And the reason being because previous attempts to as the story goes, all previous attempts to measure linear velocity using laser interferometry had failed. So he clearly believed that this was groundbreaking, his experiment, and there, which makes sense why he would try to patent it immediately. All the pieces.
Yeah, the patents prove it for sure, right?
I mean,
why would he attempt the patents if he didn't think he was onto something and it was beneficial to him?
It definitely shows intention. Yeah,
science
definitely shows a different interpretation of how other people were trying to paint it, where it's like insignificant, not a big deal. It's like clearly this guy thought otherwise, regardless of if we have, so he saw something in it, right? So
yeah, because you could always go and say like, "Oh, I didn't see this in the paper. I didn't see that in the paper." But if you look at somebody's actions,
right,
they speak. As goes the old saying, right? The actions speak louder than words. All of his actions go to show that he clearly thought this was a groundbreaking experiment that he had discovered.
Absolutely. So let's so now we got the full context of everything in the history. Let's keep going with this. So here we generalize the sagnac, or our finding of for the sagnac effect. For a more complete study of series with our new experiment, our experiment includes different types of motion with light paths of different fiber and air cores. In a study, we found that a light wave loop consisting of linearly and circular moving segments of the loop contributes to the phase difference between the counter-propagating beams in the loop. This contribution is proportional to the product of the moving velocity of the projection of the segment length delta L on the direction delta phi equals 4 pi v times delta L over c lambda. So this is independent of the type of motion and the refractive index of the waveguides. So it's independent. So the Sagnac effect, which was previously understood as only rotational, he's making the case here that the type of detection, it's independent of the type of motion and the refractive index.
Which, like, let's be fair, let's be real. Like, I don't understand how they even. I mean, I kind of understand, but we already kind of assumed that it should be measurable in the first place because the orthogonal setup of Michelson-Morley would be for linear motion, correct?
Yeah.
Yeah. So,
Well, the difference too is like they interpret Michelson-Morley as a zero, right? Or as c being constant, but we know that it fluctuates with sidereal time. Like so there's very the whole thing measures something in motion, right? Even when the configuration is stationary and fixed to the ground, there's still a measurement.
Yeah, that's a great point. They're already going off of the faulty premise that the Michelson-Morley experiment was quote unquote null,
And
right?
that
So we're kind of
and
we're
that's
giving them
and
that
rotational
anyway.
somehow.
yeah.
Or Michelson-Gale-Pearson is somehow rotation, even though it's still not a ring. It's not like it's a ring gyro. It's still using orthogonal setup.
And they can only explain Michelson-Morley with link contraction and time dilation. They need the transformation for that. That's why that's so pivotal to accepting, accepting the framework and granting it. It's literally like in a debate where you have to accept the premise of like a huge logic fallacy to like even entertain the argument. And it's like, well, I'd rather just not do that. Like if it's already fundamentally bankrupt, or like I don't have to accept it, like why would I, right?
Yep.
Like if c plus v already is the mechanism for which you're deriving the velocity, what why do I need why would I need another framework to explain that from an observer at a different, like no, why? That doesn't that doesn't make any
Yep.
sense. And they don't even do that for Michelson, Gale, Pearson, and inertial navigation systems.
Yep.
They use the classical derivation for it,
V C minus V.
which is it's like, what's the mechanism that creates the fringe? It's like the c plus v, man. There's a variance, and that variance that creates the phase difference is proportional to their velocity. Like that's it.
Yeah, that's the crux of it, right? There
That's
are
it.
I mean, RLGs already disprove relativity because c plus v, but we're like, okay, you guys are denying that. Well, let's take it a step further.
Yes.
And the same thing with Michelson-Morley, right? The fact that the fringe shifts vary with sidereal time, and that disproves because there again you have c plus v, and they're like, no, instrumental error. It's a null result. We're like, okay, well, even if I did give you that, and it's like an infinite amount of okay, well, even if we do give you this, then on to the next, and then
Yeah.
it never ends.
Well said. Alan, you want me to read for a minute?
Yeah, please go ahead. I think we're
we're at the
right
red
here.
part there, right?
Yes, sir.
This general conclusion includes the sagnac effect for rotation as a special case. The finding also suggests a new fiber optic linear motion sensor having nanoscale sensitivity, which is much more sensitive than any existing linear motion detectors. This linear motion sensor may be applied to accelerometers in navigation and seismology. Our experiments are different from the Fizeau type experiment, drag experiment of a moving medium. In the Fizeau type experiment, there is a relative motion between the light path and the medium, water or glass. The result of the Fizeau type experiment is dependent on the refractive index of the medium, and the drag coefficient is 0 when the refractive index is 1. In our experiments, as in the FOG, there is no relative motion between the light path and the medium, glass fiber or air core fiber. No relative. So yeah, so you can't try and the motion that's happening within the air core fiber on the waveguide loop. It's got nothing to do. Like the calculations are based purely on linear motion, and the length of the fiber itself stays the same.
The time.
Yeah, it's based on a linear motion and a time. Yeah, and the time. So, anyways, continuing on. Where was I?
The experimental system.
The experimental system in our study consists of a fiber optic loop, an FOG, and a mechanical conveyor, as shown in Figure 1A. A single-mode fiber loop with different configurations was added to the FOG, which was calibrated for the added length. The loop includes significant portions of fiber segments that move linearly. The function of the FOG in this experiment is to transmit and receive counter-propagating light beams and to detect the phase differences between the two light beams. Because the fiber optic gyro is not rotating in the experiment, the detected phase differences are caused by the movement of the added fiber optic loop. An air core fiber was used to verify that the phase difference is independent of the refractive index in various types of motion. The new photonic band gap fiber has a hollow air guiding core for light with a wavelength of 1310 nanometers. The fiber was used to construct a two-wheel FOC, shown in Figure 1A, and a three-wheel FOC, not shown. Shown in Figure 1B are the detected phase differences caused by the fiber motion with both configurations. The fiber motion with both configurations. Again, the fiber motion relative to what of both configurations. The length of the fiber loop is 4.1 meters. Whoa. That's longer than that's pretty long. In any case, and the speeds of the motion are from 0.00191 to 0.211 meters per second. Each phase difference is an average of 8 measurements. 13 phase differences range from 0.00246 to 0.0276 rad. The maximum conveyor velocity error is 1.7%. The least squares linear regression of the phase differences is 0.0323 VL, which closely matches with delta, what is that one? Phi, delta phi equals 4 pi VL over C gamma, or lambda, equals 0.0320 V times L, with lambda equals 1310 nanometers. It also matches the result using a glass fiber. Okay. Therefore, it is confirmed that the contribution to the phase difference in a moving light waveguide is independent of the refractive index of the waveguide and independent of the loop configuration. So you can't try and use some like kind of tricky thing saying like, well, yeah, but because of the relative motion of that particular refractive index medium, that's causing some special, relational variance to what you're measuring in the fringe shift. No. The refractive index is independent. Continuing on. To study the relationship between the motion of the fiber and the fiber orientation, we conducted an experiment in which the fiber zigzags and has an angle zero with respect to the direction of fiber motion. Thus, for a fiber segment having an actual length of delta L, its effective length is delta L cosine 0, which is a projection of the fiber onto the motion direction. As shown in Figure 2, our experiment demonstrates that the effective length contributes to the phase difference, not the actual length. Therefore, the phase difference will be delta gamma, right?
Delta phi, and then the other one,
phi.
the cosine theta, right? This the zero with the line through it's theta.
Theta, thank you, sir.
Mm-hmm.
So delta phi is not 4 pi v delta over speed of light times lambda, but 4 pi v delta over the cosine of what is it again?
Theta. Delta L
Theta.
cosine theta.
Over speed of light times lambda equals 4 pi v times delta L over speed of light times lambda, which is the dot product between two vectors. A further experiment was conducted to study the phase difference when different segments of the loop moved at different speeds. Figure 3A shows the fiber optic parallelogram, where the top arm moves with the conveyor and the bottom arm is stationary while moving. The two side arms, being flexible, are kept the same shape so that the phase difference in these two side arms cancel each other. There is no phase difference in the bottom stationary arm. Therefore, the detected phase difference is contributed solely by the motion of the top arm. The experiment was conducted using a glass fiber and an air core fiber. The detected phase differences are shown in Figure 3b. For the glass fiber configuration, the length of the top arm is 1.455 meters, and there are 11 turns. The measured phase differences range from 0.000482 to 0.121 rad for speeds of from 0.000917 to 0.233 meters per second. That's a pretty big variation, or a pretty big range. In another configuration, the top arm is air core fiber with a length delta L of 5.23 meters. The phase differences range from 0.000301 to 0.0346 rad for speeds from 0.00186 to 0.207 meters per second. The least squares linear regression of the phase difference is 0.0317 V delta L, which agrees with delta gamma, right?
Delta Phi.
Delta phi, dude. I don't know why I keep not wanting to say phi. Equals 4 pi v delta L over speed of light times lambda equals 0.0320 v delta L, with lambda equals 1310 nanometers. According to our experiments, we can draw a conclusion about the generalized sagnac effect that in a moving fiber loop or waveguide, a segment delta L with a velocity v contributes delta phi equals 4 pi v times delta L over c times lambda to the total phase difference between the two counterpropagating light beams in the loop. The contribution delta phi is independent of the refractive index of the waveguide. So still, and the motion of the segment difference of the two counterpropagating light beams in moving fiber loop experimental setup. The fiber loop is driven by a conveyor at a velocity v. The conveyor has a length of 1.2
Oh wait,
meters.
sorry. This segment.
Did I reread? Okay, I was like,
Yeah,
I guess
yeah.
it's just reiterating.
No, well, this goes into the diagram. My bad. So, and the motion of the segment, and then this part of the
Oh,
sensor.
I get it. I was reading into the next thing. My bad.
Yeah, my bad.
So there's the what we call that's the parallelogram, or I call it the slack line. Yeah. So does anyone have any questions at this point?
Yeah. So yeah. So to kind of reiterate
it's being clarified a lot more. Sorry, guy. It's being clarified to me a lot more. Like, it took me a bit to understand exactly what the issue was, but I'm starting to see it.
Cool.
So yeah, what they're describing here is basically how much wavelength, how much fringe shift pattern should there be corresponding to the motion, right? Is basically what all this is what all this math is. All this 4 pi's and stuff. This is just basically distributing the motion over the length. Is it circular or is it in a linear configuration? So that's all it is. And then the delta lambda stuff is just figuring out what the phase difference in light is going to be based off of that. So when they have that ratio gives them the velocity, down accurate down to the micrometer. We're going to find out. So if you could detect linear motion down to the micrometer, and the Earth's orbital velocity is nowhere near what is required, right? Then you got a huge problem. So this is why they tried to separate the two types of interferometry between linear and circular configurations. But they all measure the same thing when they're stationary on Earth. So they just don't and it doesn't correspond to the speeds that are needed to support the heliocentric interpretation without abstract mathematics.
Do they attempt the same experiments with the two separate devices? You know what I mean? Or are these devices specifically made for a linear experiment or a circular experiment?
So just to make sure we're all on the same page, I guess. So with a regular ring laser gyro, you would send out counter-propagating light beams. So you would send you have a coil of fiber cable in a circle, and you have the laser is split into two directions. It's going to go opposite around the fiber, right? And then the difference of that speed that it takes for both sides of it to go through the full coil of fiber and come back is where you measure your fringe shift. So the fiber optic gyro, the reason it's kind of wired like that in a circle like that in a coil like that is because the whole idea is that all we can measure is rotational motion. So if we're just measuring a circular motion, then why wouldn't you would want to use a fiber optic gyro with a coil like that, because then you're going to get the most variation, you're going to get the most precision in relation to that rotational motion. But we're not talking about, in this particular case so far here with the fiber optic or even with these experiments, we're not trying to measure any motion of the Earth. What you would see as what we would call the ether wind, or they would call Earth rotation. You would calibrate that out of your instruments or out of your measurements, because you're just trying to measure specifically what's happening in the lab. So all that is to say, up until this experiment, we have always presumed that all we can measure is rotational motion. So these particular configurations that Wang has come up with and put, these experiments, the way they were made, is specifically to show that those linear portions there. See how there's so remember I said there's like one big coil on the fiber optic gyro. Well, in this configuration here with the conveyor, we have those two long lines of fiber that are both connected to the wheel, right? And then we've also got the conveyor that the FOG sits on. So there's the racetrack, plus there's the conveyor that moves the FOG. And we are able to measure all of those linear speeds. So we're supposed to only be able, like, even when we do measure linear speeds, they have to say that somehow we're like interpreting rotational velocity to be linear. But these are these are very specific linear motions, and these very specific linear motions are directly calculated. It's all calculated, and it's calculated precisely the same way that we measure the motion of a fiber optic gyro. So it's just like really, really, we're just like getting the story straight, right? Like we're just like, can you even measure this linear motion? So let's put linear portions in here and see if these linear portions, like if the fringe shift is changed just due to changes in this linear track. And that whole thing, the fiber optic cable there, with I don't know if you can tell with the way that works, but the way that's one motion that happens. There's like they measure that one quick motion where the wheels turn, the velocities go, they're the two different sides of the cable go in opposite directions, and the fiber optic gyro goes in one direction. And that's what's being measured right then and there. So those are all linear motions, and we're talking about the fringe shift of the laser going down the fiber optic cable at both directions, right? So that length, the length of path that both sides of the laser have gone down has not changed whatsoever. The length has stayed the same. Everything has moved, but nothing, the length hasn't changed. So then why does the fringe shift? Why do we get a fringe shift? Why does the light fall out of phase in that case? If the distance is the same and the speed of light is constant, why did the light fall out of phase? And what we're trying to what this is kind of showing, as far as I can tell, and as far as just trying to figure this out, is that the absolute motion can only be detected if it's being referenced against a background medium, an absolute fixed frame, that somehow there's an absolute space. Because if the whole thing is moving, the distance of the cable is not changing, then why is there a fringe shift? It's detecting a change in the absolute space. Does that make sense?
Yeah, it does.
Cool. So this is showing that linear motion affects the fringe shift of lasers. And so the implications of that are that we should be able to go out and detect Earth's motion, we should be able to detect Earth's rotation, we should be able to detect everything really with interferometry.
Literally any motion. any absolute motion with no external input, we should be able to. Yep. Right?
Yep.
Yeah, really the most important part about this would be that it's the speed of light that's being used to determine the linear velocity in this experiment, which is, to go back to why that's so important, is because if that is the case, that the speed of light can be used to detect linear motion, then in Michelson-Morley's original experiment, it should have detected the fringe shifts, which means that since it didn't, the only, logical result is that Earth is stationary. So just to kind of bring it all back around to why relativity was introduced in the first place.
Yep.
Yep. And
Cool. So should I
Di-
continue reading, or do
yeah,
you want to take over, Alan?
yeah, real quick.
Go ahead.
Davis Gentry says, "Why isn't it C plus V or C minus V in the equation for the phase difference?"
Do you want to answer that, Alan, or?
Yeah. Sorry, I was replying to Shane. So the way that they derive it, or the way that they interpret it, is that it's basically equivalent to like a Doppler shift that's producing the phase difference, instead of interpreting it as the speed of light changing. So that's how they interpret it, that it's not an actual change. So you don't have to like C minus V it to interpret it. They can just do it through the wavelength, but the interpretation is that the speed of light is changing.
Cool.
Yeah. So like right here, actually, here's a really good example of that Wang gives for GPS. Let me read this really quick because that will help explain it a little better. So Ruyong Wang GPS and successful operation right here. All right. So when you look at the range measurement equation, which is used in GPS to determine the accurate distance of someone, down to the millimeter, right? The equation is the absolute value of R sub R times T sub R minus R sub S times T sub S equals C times T sub R minus T sub S, which is basically just the coordinates of time of signal sent and time of signal received, and the locations of those, right? And the time difference between C. So there's no C plus V in there, right? So he points out here that some people think that the range measurement equation is based on the constancy of the speed of light. On the surface of it, this may appear to be true. The speed of light is the only velocity term that appears in that equation, such as such expressions such as C plus V and C minus V, which are often seen in discussions of special relativity and classical physics, do not exist in the equation here. Therefore, people would conclude that if this equation is correct, special relativity is correct. If the equation has been proved to a high degree of accuracy, special relativity has been proved with a high degree of accuracy. For example, if it had been concluded that that special relativity had been confirmed to an accuracy of epsilon C over C less than, what is it called, 5 times 10 to the minus 10 or minus 9, but we should not judge things on their appearance. We must grasp their essence. If we analyze the implication of the range measurement carefully, we will find that contrary to the appearance, or what the appearance tells us, that what some people think of the correctness of the range measurement equation, it actually leads to the incorrectness of the principle of the constancy of the speed of light. Furthermore, the principle of relativity. It must be it may seem unexpected that that it is quite understandable if this might seem unexpected, but this is quite understandable if we compare it to sonar systems. Recall that the underwater navigation sonar uses the same range measurement equation in a reference frame based on the water to conclude that the distance would be traveled on the same, or would be to calculate the distance traveled by the sound, even though the sound receiver is moving relative to the water. The difference there is that the speed of sound in water, A, is used instead of the speed of light in a vacuum, C. However, no one would emphasize the constancy of the speed of sound, and contrarily, everyone thinks that the speed of sound is dependent on the motion of the sound receiver.
Okay, yeah, and so in this case, that's funny. This is a really good illustration of the whole argument here, right? Because, yeah, talking about how sound has to travel through an underwater navigation, it has to propagate through something, right? And so the speed of light in a vacuum has to, especially if you're going to invoke an explanation for relative or for absolute motion or for motion affecting things, then you have to acknowledge that there's something under the vacuum,
Yeah,
A
really
background
clutch
medium.
with that example, Alan. That was
Yeah.
Yeah.
that was super on point to bring that up because not only it even includes right in there that quote that you read is that's perfectly relevant. The how it doesn't need to include the C plus V in order for that to be the conclusion that you would logically draw from the ratio. So like just like how in the paper that we're reading right now, how it doesn't explicitly state C plus V, it doesn't explicitly state plus or minus C. The C variable is in there as a ratio to the motion, right? And then just like how the water is the background medium that the sound waves are traveling through in the Wang experiment, the lab frame is essentially that absolute reference frame that the speed of light is traveling through, which is going to be used, which you can add plus or minus v to in order to get your speed.
There
Yeah,
it
and that's the
is.
linearization of the sagnac effect. Like that's what the sagnac effect is.
No, but that was a great question, Davis Gentry. Thank you for asking it, man.
For sure.
That was
For
great.
sure.
And then and further on GPS and the interpretation of Doppler shift or frequency shift rather than the speed of light changing. So check this out. So what just to quickly take a quick diversion on the variance in C and how important this is. And how it's disguised in that equation because yeah you look at that range measurement equation you're like nope, only velocity term there, C, nothing going on there, right? So you think that's all good, and they say right here in the GPS what do they call it, I forget what this document's called, it's the equipment what is it, the ICD document, it's their anyway, it's the manual, it's the interface control document for GPS. So like this is their control manual document, right? So it talks about here. It says the Doppler shift of the frequency of the signal carrier is proportional to the relative velocity of the receiver with respect to the satellite along the line of sight of the receiver to the satellite. So they're saying that the speed of light is the same, and that and that there's just a frequency shift that they're analyzing that reveals the velocity of the receiver. Now that's cool. That's cool. That's cool. But here's the thing: GPS is a time interval system based off of a range measurement equation. So if C is constant, then in that distance, then the distance derived has to be um, would have to match that velocity proportional scaling. Otherwise, the distance wouldn't match, right? Otherwise, GPS would be wildly inaccurate. But it in that first measurement, it accurately derives the distance down to the millimeter, right? That's equivalent to measuring time down to the nanometer. So
So to bring this back to like Wang's equations, can we go back to those real quick?
yeah, so to bring it back to the equations here, right here.
Yeah, so uh the fringe shift, you're getting a fringe shift, and if you're going to include velocity of the optical fiber, and that's going to be relational to the fringe shift, well, what is the velocity of the fiber in relation to? It has to, it's in relation to the propagation rate. That's why the fringe shift is calculated like that. So it's just a different relationship. Just because you're not directly saying C minus V, C plus V, it's still the same. You're still describing the same relationship here.
Yep.
Yeah, 100%. You need the speed of light in that you need to measure the velocity uh, ratioed to the speed of light
Yep.
to get the answer. So it's 100% a variable that is being used in the equation, whether or not it explicitly states plus or minus the speed of light.
Yep. And then we'll touch back on the GPS stuff because that gets into a whole nother divergence thing. But yeah, so basically though, if the speed wasn't changing proportional with that Doppler shift that's producing that frequency for them to get the velocity of the observer, then their distance is going to be off, and yeah, they're going to have a problem. So the obvious interpretation is that, oh yeah, C actually is varying. Otherwise, they wouldn't have an accurate measurement there. they would have a disproportional relationship in the distance derivation, because with the time interval system being based off of c and all that, and the distance, or I'm sorry, the delay between signal propagation, the distance derived is based off of the constancy of c, right? Because it's a constant, right, in their interpretation. So they can't have a different velocity and a different frequency shift. But they somehow match. So what's the obvious deduction? All right. Okay, sorry, Toby.
So yeah, where were we? Oh yeah, we're right under down further because we're at the start of this page.
Oh, right here.
The
yeah.
red part here.
All right.
So down further because we're not on that column yet.
Yep. Oh, down here.
Yeah, here we go.
Okay.
So whatever the last sentence ended on can be linear or circular. Thus, the entire loop, the total phase difference between the two counterpropagating beams in the loop is delta phi equals 4 pi. What's that called again?
Oh, all the way down here. My bad. The integral.
Integral sub L velocity times dl over speed of light times lambda. This general conclusion includes the Sagnac effect of rotation as a special case. In fact, the Sagnac result can be derived from this general equation by assuming a circular motion of the loop and using Stokes' theorem. I don't feel like reading all of Stokes' theorem, if that's okay.
Yeah, but basically Stokes' theorem here is equivalent to 8 pi omega a over c lambda, which is basically saying it's distributing the angular rotation over the area to get the ratio of the speed of light. How much is it going to vary to produce the wavelength? Yeah.
Cool. Good explanation. Thank you. This generalization provides a design principle for a new fiber optic linear motion sensor, which has a high sensitivity and a high stability. The basic structure of this sensor can be similar to that shown in figure 3A. The linear motion of the top arm of the sensor is detected with a phase difference of delta phi equals 4 pi v n delta L over speed of light times lambda. Because two beams share the same optical path, the sensor is optically stable. Because the two beams are the same optical path. Sorry. Just as a FOG detects the rotational motion of an object, the FOLMS can detect the relative linear motion between two objects fixed on the top and bottom arms of the parallelogram. So this is talking about the slackline experiment there. The optical technologies developed in recent decades of the FOG can be utilized for the FOLMS. Therefore, the sensitivity and stability of the FOLMS are comparable to that of the FOG. The sensitivity of an FOG can be 10 to the negative 7 rad of the phase difference with n delta L equals 500 meters and lambda equals 10 to the negative 6 meters. A FOLMS can detect a linear velocity of v equals delta phi, right? Delta phi c lambda over 4 pi n delta L equals 4.8 nanometers per second, which is a nanoscale velocity. The nanoscale sensitivity linear motion sensor can detect a very small relative motion appearing in an accelerometer, which is important in navigation and seismology. The common design of an accelerometer is a spring mass system. Improving the sensitivity of an accelerometer requires improving the sensitivity of detecting the linear movement of the mass relative to the base. Utilizing a FOLMS, fiber optic linear motion sensor, to detect the relative motion between the mass and the base will greatly increase the sensitivity of the accelerometer. Interesting. It can be foreseen that an accelerometer using the FOLMS combined with the fiber optic gyroscope may be beneficial for navigation because both use the same technology and are both very stable optically. Wow. This is awesome to read this again after reading his patent.
Yeah.
We thank Dean Langley for his useful discussions and help. We thank Robert Moeller, the Naval Research Laboratory. Naval Research Laboratory. Yeah, of course they want to know about this. Why, unremarkable experiment. Naval Research Laboratory, unremarkable. The air core fiber was purchased from Crystal Fiber, Denmark.
Shout out to
What a
the
good
boys.
paper.
Yeah. So that's Ruyong Wang and the generalization of the sagnac effect. So we're going to look at the patent real quick.
Dude's like an engineer among engineers, man.
Nah, that's unremarkable dog shit. All right. Let's see here. All right. So
So
we're
I
gonna
think before we really dig in, let's just like take a moment to
Mhm.
just like talk about it and like what the implications are. This is called standalone speedometer using two spaced laser beams. So, like a standalone speedometer, you can measure. I could take this in an airplane, theoretically, and watch my speed as I travel from home to wherever I'm going, from takeoff to landing. And then I could take my time of that flight and assuming a linear path of the flight, which may be a bit of a not necessarily a perfect assumption, but you could you could actually start deducing actual distances in your flight based on your speed and time traveled. Uh, this could actually be a problem if there is something being hidden in the southern hemisphere as far as technology is crazy. Being able to detect absolute motion like this, the implications, like there's probably a bunch of implications I haven't even thought about, you know. But yeah, so it's like a standalone speedometer. You could run with it theoretically. I don't know how big it is. I don't recall off the top of my head, but like you could run with it. You could take it in your car, take it on an airplane. No matter what, you don't need an outside frame of reference, and you can detect your actual speed purely using interferometry. So if you really think about that, like really try to like contemplate that, take that in, like what does that mean? How is that laser? What is it being like? There's some kind of a fringe shift happening there, right? Like you would think of like a wind or something. Like as you ran, the lasers are being blown in the wind, and so you're measuring that. Well, what's the wind? What is like if you're running with a couple of flames, you would see the fire go backwards, but that's because it's relative to the air, and as you're running, the air resistance is pushing the flames backwards. But like with lasers, if it's a standalone unit, what is pushing it backwards? And that's why
Your boy
there's
Ether.
exactly. That's why this is such a big deal because it implies a background medium. It implies that we should be able to measure the motion of the Earth. It implies, yeah.
Well, what I find funny too is that like if you just take that standalone portion off of the description and just say speedometer using two spaced laser beams, that's literally the Michelson-Morley experience. Like they already that is like that's the
Yeah,
description of
true,
MMX. And
true,
then
dude.
man came along, he's like, bro, I can make this pocket size. You know what I mean? Like, but that goes more to answer the question of like why this would be considered such a landmark monumental experiment is because this experiment had been tried before and it was the most famous failed experiment ever. And then this guy comes along and he's like, wow, I made the experiment work. The most famous failed experiment ever. I got it to cooperate. So
And how did he do it? He just didn't lie about the results. That's all it took. He just didn't lie about it, and then that's it.
yep.
He wasn't like, "Oh, look, it measures a proportional linear velocity directly. Hold on, let me erase it through obscure mathematics." No, he was like, "Oh, this is great." Okay, cool. So, yeah, great introduction to it. So we kind of went over the history earlier. So this is the document in question here for the patented technology based off of those experiments that Wang was doing in 2003 and 2004. All right. So here's the configuration here. So he gives like several different configurations here. So like different prototypes or what have you. So we got your single laser source here, and it outputs a beam in both directions here, W1 and W2. Hits a reflective mirror, hits reflective mirrors, gets recombined, and hits the detectors. Now he comes up with a way to make sure that these waves are in phase before they leave this area. So when they come out here, they're in phase. They're all proportional, and then the phase difference produced by your motion, by your relative velocity gets measured against what's called a preferred frame that we'll learn more about as we scroll through, which may or may not exist, according to some people. All right, not sure what this is. So here's some just different iterations of the same thing. So this is just kind of highlighting, picture a yellow beam, and then a green beam, and the phase difference produced on either ends of this is how he derives the velocity. So here's the configuration with the what do they call transparent photo detectors. So these here ensure that before these waves leave, that they're in sync. So it just ensures accuracy, stability. And then the modulator, coupler, mirror, same situation, just more accuracy. And then he has I think he came up with a, what do you call it? Yeah, a ring laser. He came up with a standing ring laser configuration. So for those of you at home, this is just a fiber optic loop.
Yeah, if you go to Wikipedia and look up the sagnac effect, that's literally the diagram that is.
This is literally a
that they
fiber
give
optic
right there.
loop. So this isn't even a laser at this point. So like you could deploy this because here's the thing: the sagnac effect is proportional to the amount of turns in the coil. I mean, sorry, not proportional. It's enhanced by the amount of turns for the coil. So you could have like really small. It doesn't matter like the length. I mean, obviously with more length is you'll get more out of it or whatever. But yeah, but you could literally do it with like the fact that you could do it with a fiber is just good game.
Yeah.
So yeah, and then he goes on to say that you could take this and have a configuration where an XYZ axis is compensated for, and that will measure absolute velocity in 3-dimensional space by just having 3 of these on an XYZ axis with no external reference. All right. So the Michelson-Morley device that's used to measure absolute space against spaced laser beams, cross-reference. So let's see. The provisional patenting in 2004. Field innovation. Was there anything? Did we? Oh yeah. Let's look through here. So he gives the how he's using C in here. So neglecting terms of the higher order, higher than the first order, we have a speed of light u. So how's he using the speed of light? So u equals c over n minus e times v prime over n squared, where v is the velocity of the apparatus relative to the preferred frame. C is the constant of the speed of light in the preferred frame. N is the refractive index, and E prime is the unit of the vector of the direction of path. So, Toby, what are your thoughts on this analysis of how he's using C for his apparatus?
I mean, that's just more of what we've been saying, right? It's a preferred frame relative to the preferred frame. What is a preferred frame? Maybe reality, maybe the background medium, absolute space.
So if he's measuring this against absolute space, and we look at his paper, where he's not saying that there's any plus or minus to C, how could he possibly be interpreting the fringe shift pattern unless it's through just the absolute motion of the device?
Yep. No, it's the
So
absolute motion, of the fiber cable, the waveguide loop. Yep.
so you could only really conclude from that, just like philosophically, you could say speed of light's the same, blah blah blah. You could reference frame, you could transform, you could interpret it differently, right? But the effect here, and measurementally wise, the only interpretation is C plus V, C minus V. Otherwise, this technology doesn't work, right?
Yep.
Cool. So that's
Yeah, if you go over, I was going over that paper by Tartaglia as well, and it literally admits that in plain English as well. Says that the Sagnac effect may be easily described in classical terms if one assumes that the speed of light is c with respect to the static ether. That's the easiest explanation, the testable explanation. You can, like you were saying, you can add a bunch of abstract mumbo jumbo and try to come up with other explanations, but the only testable one with that we can actually empirically verify using the laws of physics would be C plus V with with an ether.
Yeah, let's pull up that wizardry.
I just pulled it up right now.
Yeah,
Yep, sure did.
I really like. Thank you for sending me that, by the way, Toby, because that was so enlightening to read through that, and then especially given what the conversation that you and Alan just had. Yeah, man, that was great. How they basically just the entire thing is trying to use a Lorentz transform equation, which was, from what I understood, that was being denied in the conversation that you guys were having. So that was very enlightening.
Yeah, it depends which part of the conversation you listen to.
Yeah,
it depends on your reference rate, bro.
That's a good point.
What was the exact phraseology here? I'll just search for it so we can skip right to it.
Section 2.
Section 2.
Yep, right there.
Oh yeah, right here. Yeah, the Sagnac effect. So the principle.
You already got it highlighted. Yeah.
Yep. The physical principles of the Sagnac effect are explained in full details in the well-known paper by Post 18 and can be fully summarized. It can be summarized as follows: the Sagnac effect can be easily described in classical terms if it assumes that the speed of light is c with respect to a static ether. Considering the rotational platform, blah blah blah, right? So do we have that? Oh, dude.
Well, can you pull that back up real quick? Or I don't know if you want to finish your train of thought. Go ahead. Sorry.
No, you're good. You're good. Talk. I'm gonna pull up.
While we have this paper up, I would just like to just go to the Lorentz transform real quick, just to show everyone that is listening, following along here, that they can't even explain a local Sagnac effect, like a rotational local Sagnac effect, without invoking a Lorentz transform. Like if you want if you want an explanation in a relativistic framework, you have to invoke a Lorentz transform just to explain the Sagnac effect locally.
Yep. And where do they put that observer when they coordinate system transform on the cylinder again, so that they could flatten it out later and
nice
analyze
convenient spot, right?
Where's that spot located at?
Center.
In the center. So, like, if you were to come up with an experiment that forced the location of the observer to not even be on the rotating device, and was actually stationary, like, do you think would you be like, oh, you know how I'll interpret this by mathematically putting the observer in the center anyway? Like, do you think that would be like a valid way to continue justifying the constancy of the speed of light rather than going, oh yeah, it's c plus v?
Yep. So yeah, go down. Did we already look at the transform itself?
Yes.
Okay, cool. All right, cool. Yeah, you can. I don't know if you still remember your other train of thought you were on.
Oh yeah, I was gonna pull up the Bennett short where he just explains the Sagnac.
Dude, yeah, we haven't even looked at Bennett's analysis of this yet.
I totally forgot.
I mean, I have before in the past.
Dude,
but...
Oh, you know what? You know what we're gonna do live right after we finish this patent?
Pull that up.
Yeah, immediately.
Yeah.
So let's see here. Let me go to my shorts. I just wanted to play this real quick. Should have just played this to explain it. So let me change screen share real quick so you guys can hear it on Discord.
Oh, nice. Yeah, that's a good video to play. And then I was just thinking his actual paper on it.
No, yeah. As soon as we're done with the thing, we're gonna pull it up because I've already been.
But you're right. This is a great view for this. Yeah.
Yeah, this is a great explanation of the Sagnac effect. Sorry for not playing this earlier. Shout out to Robert Bennett. If you're watching right now, please join us in the chat, brother.
Okay, here's the experiment. Send down a signal in both directions. What's the reason for splitting the beam? So that they start at the same time. Why not have two lasers? Well, there's no way you could tell when the two light waves started off exactly, because remember, they have periodic variations, so the phase would be different. But if you split one beam into two, you know that they're both in the same phase. And then they go around. If the disk is not spinning, then they will go equal distance and they will arrive at the opposite diameter. What if they are moving? What if the disk is rotating clockwise? Then the red path will get a boost from the dragged ether on the circumference of the disk, and it will be able to travel further than the blue line, which is bucking the flow of ether. It's going against the dragged ether. And so there will be a shift in the position, and you can measure that with the interferometer.
All right. Yeah, great clip. Great concise explanation of the sagnac effect. So what he really meant was, if a device is rotating and you're an observer watching it, if you transform into a cylinder above that device for convenience, and then you align yourself axially with that rotation, you're now in the center of it. Okay, that makes way more sense. All right.
Yeah, just, I mean, again, simply put, like at its bare bones, if anybody wants just the reason why RLGs, fiber optic gyros, the reason why they falsify relativity is because if an object's velocity cannot be added or subtracted from the speed of light, then there would never be any change in the fringe shifts, and those technologies wouldn't work at all to begin with. So like right there at its most foundational premise, the fact that sagnac works at all, is a falsification of relativity. But of course, then they'll begin spewing abstract mathematical equations to try to cover that. But that's the truth of the matter.
Yep.
Yeah.
And that was Sagnac's original interpretation. So, all right. So there's the patent. There's the technology. Where's the other damning stuff here? See, this indicates the time difference between the two beams related to C, or is related to V, the speed of the relative to the preferred frame. So more on the preferred frame, which means that the time travel difference of the two space laser beams is a first order effect of V times L over C squared, where V is the relative frame and L is the projection of the path on the direction of the velocity. The projection could be positive or negative depending on the angle of the path and the velocity. All right. I think let's see, read a little bit of this. I'm just going to kind of read over the red highlights and then we'll exit out of this.
Sounds good.
Okay.
I like it.
Two beams in the main part of the speedometer propagate in the same path but in opposite directions for two detectors. Therefore, the speedometer is optically stable if the difference between the two detectors is used. It is important for a speedometer mounted on a moving object. When the speedometer is moving at a velocity v, the speed v can be measured by comparing the time differences before and after turning the speedometer 90 degrees. And so he gets into the different configurations to average out the readings, but then he says here that you can just make a configuration where you have an XYZ axis covered, and it'll give the absolute motion in 3-dimensional space without needing to take without reorientating the device for the readings. So he's given out different configurations for it. So this fiber speedometer is similar to the fiber optic conveyor. Oh, no way. So what does that mean? Dude, come on, bro.
Yeah.
So it's similar to the fiber optic conveyor situation. Therefore, the difference between the blah, blah, blah. So it gets into how the linear motion is, causing the phase shift. And then here I have this highlighted with a bunch of crazy stuff. So this is probably important. We'll see what this says here. So it says another relative construction for the standalone speedometer is described here under the reference where there are two space light beams with the round or emitted from a ring laser. Both of the beams change directions on the couplers and with mirrors. The interference fringes and time differences are detected with two detectors. The standing wave detector will be located in the laser cavity. An apparatus using 3 standalone speedometers can be used to measure 3-dimensional space. Oh yeah, so that was that. So that's pretty. So what they explicitly say can't be done. This dude's like, well, not only can it be done if you just reorientate the device to take the measurements, if you just have a device per axis or axis, you're good to go.
Yeah.
So then he gets into what does this patent claim to do? A speedometer comprising of a laser. Okay, and he gets into the specifics of what's in the diagram that we went over earlier. So this is just all the bits and pieces, and then part 2 of what is claimed: a method of directly measuring the translational speed of a moving body comprising of a laser cat. So then he just reiterates the equipment and says changing the light beam's direction, blah, blah, blah. And then D, converting the phase difference to a translational speed of a moving body. Toby, real quick, what produces the phase difference again?
Well, it must be relative to something, huh? Maybe an absolute frame, an absolute background medium.
So you're saying, do you see?
Oh, the speed of light. Yo, Brian, you're hot micing. No, you're good. What were you saying, Alan? What was the question again? Converting said phase difference to the translational speed of the moving body. So the phase difference is caused by differences in the velocity of light or the
no, sorry. So the point here being is that the phase difference is caused by the change in the speed of light. Otherwise, it couldn't make the measurement. Otherwise, there's no need to reference a preferred frame and absolute space and all these things. You could just not talk about it that way. But for the accuracy of how it works and functions, it's not that.
Yep. So yeah, there we go. That is
so that's his patented technology.
Pretty insanely cool concept. Pretty cool, insanely cool idea. Can't say I've ever seen it used in person, but there's the patent. He's still talking about this. He filed that patent 19 years ago. It was then patented in 2009, or he filed a preliminary patent work 19 years ago. And yeah, he's still talking about more waveguide loop and linear interferometer setups to further falsify relativity. He just put that one out a few years ago, and then he's still talking about preferred directionality of light. Yeah, so I mean, it's you either acknowledge what's happening, look at his experiments, his data, or look at his findings, acknowledge it, or you have to just assume he's just a total kook, such a kook that he spent 20 years obsessing over this, even though supposedly it's unremarkable.
Yep. All right. So let's see.
Well, and he's such a kook that his conclusions agree with pretty much everybody else's conclusion. Like I love in that Tartaglia paper the quote that Alan just read, where the key word there is easily, right? The Sagnac effect may easily be described in classical terms if one assumes that the speed of light is c with respect to a static ether. And then the rest of the paper goes on to explain it uneasily. We know the easy way to explain it. Now let's try the convoluted, abstract, unconfirmable, unempirical, reified way of explaining it.
Yep. I'll be.
Wang.
Yep.
Wang was definitely not crazy. Put it that way.
Yeah. Before we continue, I'm gonna go use the restroom real quick. Take a quick break. Yeah, we'll regroup.
Yeah, let's take 5
because this is gonna be this is a long paper, but this definitely gets to the heart of it, and it goes over a lot of different. Yeah, we'll take a 5-minute break.
Chill time. If anyone wants to chat it up, I'll be right back.
Yep, same.
Yeah, sorry about joining in hot like that. My app changed. I say that to anybody else join Discord, they changed it. where your mute button might look like it is muted, and you might be hot mic'd. That's what just happened to me. That anybody who didn't see that conversation that they just had with that's the guy who does the he counts the fallacies, the logical fallacies, and he does some good videos. And they y'all need to go watch that. If y'all missed it, go watch it, because this is right down to the crux, man. That's some jam up conversations. I'm a little bit confused when they come back. I'm going to ask them why y'all. To me, it's not philosophical. To me, the linear tests break it down, and I might be missing something. I joined to get a little clarity on
Brian, what they're saying is that it's philosophical with regards to the contrary position. So if you're taking what's empirically verifiable, if you're taking it as the results clearly show, that's one philosophical position that you have. The philosophy being that we can measure things as they appear in an absolute reference frame. And then the opposing philosophical premise would be, no, that's just, reality trying to trick you into thinking that you can measure things in an absolute lab frame and that's reality. But in reality, we can apply Lorentz transform equations and also, in addition to that, everything's relative and you can never prove anything. That would also be a philosophical premise. So I think that's what they meant.
He was taking the position that, like, trying to get a concession, like.
Oh, you mean I can science that? Like, is that what you're talking about?
Yeah, I can science that. It was acting like they owed him a concession. I'm like, bro, every time he asks you what the apparatus is relative to, like, you don't got to bring up relativity and say this is classical. He means literally what's causing the friendship, the light traveling, what's it in reference to. He never once answered that unless I'm missing something else.
No, he did. Yeah. He accidentally did.
He did accidentally
said it.
He said an absolute space at one point or something along those lines. Yeah.
Right, and then he tried to concede it every time after when you tried to throw it up, because that's the crux of the whole conversation is what is in reference to what we're measuring. And I thought he did a superb job of dodging that question the whole speech, man.
Right.
That's okay though. He agreed if we never bring it up again, he'll change his name to I Can Kinematic Concept That.
Nice. Yo, Brian, did you see the patent we just had up? Did you happen to catch that at all?
No, but I heard about it. I wasn't able to look at it, but yeah, I heard about it with the dude. I was one of the first people to bring this point up a while back, and it didn't catch. And now y'all ran with it and went in depth with it, which I appreciate. It's awesome, dude. This is right over the target, and with the speedometer and the linear motion, man, that's huge, man. Can you tell me a little bit more about it? Because that's the only part I caught, man. Was
that's funny patent. You say. It's so funny you say you kind of had that thought before, because that was like, it was fun when me and Alan were going through the paper, Wang's second set of experiments with this. Like when we got towards the end and we were talking about it, I'm like, I feel like this is crazy, because you could like bring this on an airplane and you could travel where we think there's like discrepancies with the GPS, and you could actually measure your absolute distance theoretically, right? And I was like explaining that to Alan about how this could like be a game changer for measuring actual distances, because you don't have to have like a relative, you have problems with the relative frame with airstreams and stuff. And then Alan's like, oh, yeah, actually, he has a patent on this. And it was like, oh, it's literally a speedometer.
And that's the whole point. Is like when you was bringing it up, he's acting like he's trying to use that for his argument, saying that about the lab frame and stuff, like or putting it in the back of a truck or an airplane. I'm like, bro, that's the whole point of the Michelson-Morley. Then he's like, well, I don't want to bring up other papers. I'm like, what, dude? That's the whole argument is what it's measuring, what reference frame it's measuring, dude. That's baffling, dude. Good job, dude.
Thanks, yo.
Crushed it, Toby.
Yo,
but
so did you.
it was needed, bro. Like, and it all worked out, man. This is great.
Yeah, dude, it's good. I love it because for me, Wang's experiments are they make it all so clear, right? Like it's we need to own these experiments. We need to raise them up on a flag, and we need to like own the crap out of them, know them better than anybody else, and just like yeah.
Hey, and but I do. If he's listening or happens to hear this, I'm not trying to be real critical. This is just my observation, my opinion of what I heard, and I like the guy, and I'm glad that y'all settled it down in the end, and so you were able to listen to hopefully some more conversations y'all have. But when he kept saying like when y'all were bringing up the point that about the relative in the truck and whatnot. Dang it, hold on, guys. I'm so sorry. I got a hell of a point to make and a question to follow it up, but give me 1 second.
Yeah, old sagnac. All right. So
Okay, yeah. Sorry about that. He was making the point that you don't have to use relativity, and I'm like, wait, that's not the point. The point is special relativity was used. I mean, you actually pinned it down even further by stating the fact that you have to apply the Lorentz transform and whatnot. But on its face, just SR when he's saying that it's not necessary. What do you mean? Wait, what do you mean it's not necessary? It should work either way. And the fact that we don't have to apply SR, ain't that a problem on its face? Am I missing something? What am I missing, man?
No, I hear you. I'm on the same page.
it's
You're not missing anything.
yeah, it's so simple. It's one of those things where you gaslight yourself. You're like, it can't be,
Yeah.
right? Because when I started looking into the Sagnac effect, dude, there's like 10 different answers they give for it. And then like the end all be all mother of all is Paul Lavou's derivation of it with general relativity, which is just convoluted mathematics. Yo, what up, Bennett?
Hey, how are you, brotherly dudes?
What's going on?
How's it going, bud?
Welcome. So glad to
What
have
you
you.
talking about?
Talking about Ru Yang Wang.
You
Yep.
got your paper up.
Yeah,
Really?
yeah. Go ahead.
Just got back from the hospital with my wife with a broken leg. So
Oh
Oh,
man.
geez.
yeah,
Sorry
this
to
is
hear.
what happens when you get old.
Oh man.
Don't fall down because the bones can't stand it.
Well, sorry to hear
Anyway,
that. I hope she's all right, and thanks for popping in anyways.
yeah, I think it was Alan who sent me an email that I think it was at that conference you had in Florida,
Oh
the Mount Meru.
yeah. Well, it was online, but yeah. I didn't go anyway.
Yeah, well,
but yeah.
the question about um, what the vortices meant was interesting. The physics girl video, which I saw a couple years ago,
Oh
and then
yeah.
basically forgot it. Yeah, I forgot about it, but that is one of the most important, I would say, videos for ether research because it shows the full toroid visible with the dye and everything.
Yup.
And it and like you pointed out, Alan, you could extend this to the atmosphere where the high and low pressure areas are just the cross sections of the toroid. So you have half of it underground and half of it in the atmosphere. And the high and low are the counter rotating ether currents. and you could extend it to tornadoes, except that with tornadoes, you have to explain where the other half of the toroid is. If it's clear when you have the high and low pressure areas, which extend for hundreds of miles. But when you have the tornado, which is in a limited area, where does the other end of the tornado come back down to the ground?
Yeah.
If you could figure that out.
Oh, that would. Oh, I see what you're saying. Yeah, that would be. Okay. Yeah. Okay. Yeah. Yeah. That would be interesting.
And I think you expressed the idea that the vortices, the toroidal vortices, were perturbations in the ethosphere. That's basically the research that I think the Russians were looking into, the effect of ether research in the weather prediction.
Dr. Bennett, did you just see that conversation they just had?
He didn't
With,
see it, Brian.
I can,
Yeah.
No, I just got here.
Yeah, it's fine. Please
you're gonna be
continue.
delighted, brother.
So the
Well, I'm
sorry.
delighted with the interest that you guys have in the basically the sagnac effect and the Wang, because I've been trying for a long time to get anyone interested in what seems to me to be obvious conclusions that you can draw, namely that the speed of light depends on the speed of ether. So it's always c plus the speed of the ether, which is usually found by figuring out what mass is dragging the ether. And the fact that you can predict that the laws of physics will only work in the lab frame, it seems to be a topic which no one seems to accept or to understand, even though it's pretty obvious from the Newton's bucket and many other experiments. I did see a video that Toby had with Matt, the science guy.
Oh yeah.
You know what I'm referring to?
Yeah.
Matt, Toby, and Alan, I think.
Yeah.
Right?
Yes, sir.
Yeah. The question came up. How do you define an orbit? Is the satellite orbiting the Earth or the Earth orbiting the satellite? Well, the claim was made that the satellite is orbiting the Earth because that's what we see. But if you were in the satellite, let's say from the Earth, the satellite was orbiting every 2 hours, you would see, if you were in the satellite, you would see the Earth orbit you every 2 hours. One in the counterclockwise direction, the other in the clockwise direction. So that's because it's kinematics, and kinematics obeys relativity. When you come up with an argument like that, what is orbiting? You must reflect. You must resort to the laws of physics, and the laws of physics, when applied to orbiting objects, predict that if you're in the Earth frame, the lab frame, the laws of physics will correctly predict the orbit of the satellite. But if you're in the satellite and you apply the laws of physics, it will not correctly predict the orbit of the Earth around the satellite. So in dynamics, we can distinguish motion, but in kinematics, measurements, we can't. As long as you keep that rule clear in your mind, you'll be able to answer all of these questions that come up where they challenge, by confusing kinematics and dynamics, they confuse what's moving and what isn't. Any questions on that?
No,
Well,
thank you. That's a great argument to. That's very concise and
Very, yeah.
it's perfect. That's my new. That's the new meta.
It's like write that on an index card and keep it in my wallet type of thing.
Yep.
It's so relevant to you guys to what the topic is we're talking about too, about sagnac, right?
Yep.
Yeah.
That's really is the issue, like he outlined right there.
Yeah, because we literally just had a conversation with I Can Science that a couple of hours ago, where his interpretation of Wang's paper was that it was unremarkable and that it measured relative linear velocity against its against some other type of linear velocity within the configuration, even though the paper explicitly goes into great detail to explain that that's not the case. That was the explanation that was put forward, and it was yeah, you can check it out later. It was interesting, but yeah, it's like this is literally the crux of the issue, and it's like the argumentation was like, Wang doesn't say that there's a preferred background. Wang doesn't show that the speed of light is c plus v in the paper, but it's like you look at the equations and how they're deriving the frequency shift, and it's proportional to the velocity of what's that, the speed of light. Like, I don't know, man. It seems so straightforward that like you almost start questioning yourself, when you when you hear the explanations. You're like, oh wait, is it like, does that even make sense? But it's like, yeah, is the satellite orbiting the Earth, or is the Earth orbiting the satellite? The age old question: is Schrodinger's cat alive or dead? It depends on which reference frame you want to believe you're in.
Yeah, that's something you have to overcome, is the reliance on old arguments, the resort to what they've been told or what they thought they understood, which have been disproved really since Newton did the bucket experiment.
Mm.
And you could do many other experiments like the hitchhiker, and there's many others that you could do that show that only if you're in the lab frame do the laws of physics correctly predict what will happen.
Well, what was
I
really
did-
interesting about their... Sorry, go ahead, Bennett. Go ahead.
No, I was going to say that I heard some arguments about which is more accurate, the MMX or the sagnac experiment. Well, whenever you have an interferometer with what do I call it? Perpendicular arms. In other words, where the two beams, the two half beams, cross at a right angle. That's an MMX type interferometer. And that has an order of V squared over C squared in its error. But the sagnac has an order of V over C. Since V over C is a small number, the sagnac experiment is more precise than the MMX or any other experiment that uses the orthogonal path for the two light beams. When the light beams go in opposite directions on the same path, that's a sagnac type experiment, and that's always order V over C. So between the two, you always prefer the sagnac because it's closer. It's easier to the experimental verification because it has a smaller error than the MMX type. Any questions on that?
I was just gonna say that it's funny because in the conversation they just had, I Can Science that even admitted that he said that C plus V was a valid interpretation of sagnac, which I think is very relevant to your Newton's bucket point there, where it's he won't come out and say it, but it actually is the only interpretation that's viable is C plus V from an experimental standpoint anyways. I just thought that was interesting.
Well, how do you reconcile sagnac getting C plus V and Einstein saying that the speed of light is always C?
Yeah, you don't.
No, you don't.
They're
No.
irreconcilable, yeah.
Irreconcilable.
Yeah, unless you want to. I mean, the only other way is to leave the lab frame, right? And they literally, when pushed with their backs against the wall, apparently, they are not afraid to then claim a Lorentz transform to make it all make sense.
Yeah, well, that's another issue. When we talk about covariance, the Galilean transformation is valid for mechanics. All the laws of Newton are invariant under a Galilean transformation, but the Maxwell equations are not. The Maxwell equations are invariant under a Lorentz transformations. So if you have to take the choice based on Sagnac and Newton's bucket, you should choose using the Galilean transformation in the Maxwell equations and making both sets of equations invariant under the Galilean transformation. But the difference that how can I put this? The resolution of the difference between the two sets of equation is found by including ether in the Maxwell equations. They're called the Maxwell-Hertz equations. When you include the motion of ether and insert that into the Maxwell equations, then they become Galilean invariant. In other words, we have a unification of the two sets of equations for electricity and for mechanics that were established long ago. Now, what has happened in mainstream thinking is, oh, Einstein is correct, so it must be mechanics that's wrong. So they apply the Lorentz transformation to mechanics, to Newton's laws, and that creates all of the errors that they get experimentally when they try to unify electricity and magnetism and mechanics by using the Lorentz transformation for both. So it was Einstein that really caused this problem by introducing the Lorentz transformation and the constant speed of light. What you have is a conflict which was resolved in the wrong way. I can give you some references maybe tomorrow about what how to include the ether in the Maxwell equations so that the two sets of areas of physics are compatible.
Oh yeah,
Mechanics and
absolutely,
electricity.
absolutely. Please
I'll
send that to me.
also I have an update on the Alley effect. Some people think they have solved the problem. I don't have time to discuss it, but
Ooh, okay,
I'll send that along tomorrow.
nice, thank you. Okay, and so
I
so
got the
you're
phone.
go ahead.
I got the phone ringing, so I got to run. But I just wanted to catch up with you guys because I have been watching your videos, but I haven't been responding.
Oh, no worries, bro. Yeah, hit me up tomorrow, and we'll talk.
Yeah, thanks for popping in.
Okay.
Really
Yeah,
appreciate
yeah,
hearing
appreciate
from you.
it.
Always
Okay.
good to hear from
Okay.
you, Robert.
Okay.
Yeah, I
Take care, guys.
hope your wife feels better, man. And
Yeah, hope she recovers all right.
Yeah.
It was a
Yeah,
speedy
we'll be
Yeah,
sending good
she's
vibes to
gonna.
the ether at you.
Yeah, best wishes.
Yeah, Ethan. Okay. Thank you.
Thanks, Robert. Heck yeah. Well, cool. Now I guess we can dive into his paper.
yeah, came
That
in
was
hot.
synchronistic. He popped in just as we were about to go over his work.
Yeah,
That's
that's
awesome.
awesome.
And,
I'm gonna disconnect him. So
Yep. Okay.
cool.
Yeah, it's funny. It's funny how he's when he says like, oh, I was just trying to get people
Shit.
to see this with my work, and I hope, and it's like, oh yeah, I think you did a good job with that, bro, because that's why we're having these conversations. I don't
Right?
like. at least for me, it was his work and Robert Sangenis's work that literally led me to my first like research into which was pulling up Elias's paper that he did breaking down Miller's work. That was due to a video that I had seen based on his, what was that documentary he did, the video that they put out on geocentrism? I forget what it was called, him and Sangenis. Anyways,
I've never seen
he had
that.
put out a,
Oh, the principal.
the
Wait,
principal.
Bennett's
yeah.
Bennett's in the principal?
Yeah, yeah. He has a he's in 2 scenes
Oh,
for
dude.
like 4 seconds. Yeah,
I never finished watching it. Dang, now I
Yeah,
gotta
Bro,
finish
the
it.
he's in the beginning and I
bro,
think
the
in the
thing that
end.
Yeah, the thing that
Dang.
really was grinding my gears about Michelson Morley, because Witsit had like really sparked my interest in it, like, and I was using that as like my like my main gun, you know what I mean, in debates. And then they hit, and then I was getting hit with, okay, well, what about modern day perpendicular Michelson Morley types? How come those don't detect the fringe shifts? And what about the instrumental error argument? Because the fringe shifts that they detected were gradually throughout the years kept on reducing and reducing, and I could not find anybody that was really addressing that. It had been brought up in a debate by Bryant Myers with Witsit, but it was that debate with where Dave Wise and Jaron and they had moved along before addressing it. So, and then I found, because I watched that principal documentary and they had mentioned that, I believe it was either in that documentary or in a video about that documentary. And they had mentioned that Elias had done a critique of Einsteinian relativity and broken down Miller's work. And I was like, oh, Elias did. Well, let me look him up. And of course, his Wikipedia page had nothing to do with it. So I just hopped on a couple different search engines and then found the Elias's breakdown of literally like his whole thing that broke down, how it was directly correlated to sidereal time and all of that. And all of that can be traced back to Sangenis and Robert Bennett's work. So it's so cool to hear him say like, oh, I just want to get people to kind of notice this or see this, or I just hope people are like can use my work. It's like, yeah, dude, like he is the inspiration that got me into this topic. So it's cool, man. It's like but it's like my own personal like number one celebrity pops in every once in a while and talks with us.
That's awesome.
It's badass. I got Bennett up on the screen there from the principal at 1 minute 8 seconds. He's in the frame there.
Gonna play it?
It's just like I'm not switching screens for it. It's like literally 2
Oh,
seconds.
gotcha.
He just has like he just says like two words and then it cuts to somebody else. But,
Gotcha.
but yeah,
That's
he
pretty cool.
had a quick cut in there. So he's like, hey guys, relativity shit, and then it cuts to this guy. Paraphrasing, of course.
Alan,
All right.
I got a question for you.
Oh yeah,
when
yo,
when
Brian. Sorry about that. I didn't realize he was gonna dip right after that, so I was waiting to like segue you
yeah,
in.
that's cool, man.
My bad. Sorry
I
about
get
that.
it. I understand.
Yep,
No,
go ahead.
no worries at all. Y- um, I was wondering, okay, with the Michelson Morley style interferometers, I realized that the setups were large and everything. Do we have the technology, or I don't know how deep you've looked into this, but what happens if we put a device like that, or maybe a modern day equivalent to that on an airplane? Would you equivocate that with like the atomic clock type of experiment, or you know what I'm saying? What can we use them type of devices for linear motion?
Well, you could, I guess, but like Bennett was saying, the air margin's greater on it for the orthogonal setup. So you would just
Right, because when I sorry, when
Yeah,
I
you're
look
good.
into it, man, they always talk about displacement, and it's like, what's the difference between displacement and motion? When they talk about the precision of this displacement, it seems like it's just incredibly precise. But it almost seems like to me we might be missing out on technology that we could have and still could, really, the way I'm thinking about it. We could upgrade and get like speedometers and whatnot off of Well, of course, now they found a different way to do it, which I guess is equivalent. But what I'm saying is, it seems like we missed out on possible technology just because of their interpretation of the results of the Michelson-Morley. It's crazy. See where I'm going
Yeah.
with that?
Oh yeah, no,
Yeah, that's
absolutely.
kind of what Bennett was saying. Yeah, go ahead.
Yeah, that's what Bennett was saying, and that's what Wang, Wang wasn't afraid of that, but that's absolutely it. There's a whole plethora of
Yeah,
stuff that's been hindered by this.
Brian, to kind of expound on what you were just commenting on right there. Yeah, for sure. Of course, if they had taken the technology, if they had taken the results of the experiments and read them at face value, then we would have made God only knows how many drastic improvements in this technology over the past century, right? Way more than even probably, definitely more than what Wang discovered. We would have had, God only knows where we would be. But just to kind of give you just another physicist's take on it. So there was a quote from Richard Wolfson, who was a physicist that I had saved this quote, and he had said that the Michelson-Morley quote was an experiment that was able to measure. He said it could have detected speeds as low as 2 miles a second instead of the known 30 miles per second or 30 kilometers a second that the Earth as its orbital motion around the sun, and it didn't detect it. So he goes on in that quote to say, well, the implications of that are that Earth isn't moving. So according to Richard Wolfson, again, I haven't looked at the technical specs of the exact error margins of the Michelson-Morley, but according to Richard Wolfson, who was a physicist commenting on it, it could have measured speeds as low as 2 miles a second, which would be something like 7,000 miles per hour.
Yeah,
So
that's still pretty fast.
yeah.
Can
So
you-
but an
can you send me
airplane, so
that?
an airplane or a train, no. Yeah.
Yeah, that's good. That's good stuff because I was kind of wondering. That's really good. I've been wondering that same thing. So yeah, if you could, when you get it, Alan, if you want to share with me or whatever.
Yeah.
Here, I'll send Alan that quote right now.
Yeah, and I'll dig up the paper and stuff on it or whatever, or get the more references to it. I know.
Yeah, for sure. Because
Yeah.
I actually had that question proposed to me quite a bit in like the early days of me looking into this. Was people used to say that all the time? Well, why could you put a laser into? They use it not an airplane, they use a train. Right? I used to get this one guy who was like, well, if we put a Michelson-Morley apparatus on a train, would we be able to determine the train speed? And of course, the obvious next step for me to do in order to refute that would be to find out what the upper limit was on the error margins of the Michelson-Morley experiment, which was actually really hard to find. So that quote right there that's really all I have on it, unfortunately. But I'll send that to you, Alan, and maybe you can find out where that was from.
It's funny you mentioned that because I'm actually on the hunt for the air margins too. So I think Paul Drew might have them in his book of optics because he goes hard in like chapter 8 on it about the Michelson-Morley experiment, and then he has like a whole nother chapter dedicated to it. And I've only read like a little bit of it before I started doing other stuff or whatever. But yeah, there's definitely some ends to chase down on there for the accuracy. But yeah, the way that I like to argue it, is I just pull up the Michelson-Morley, and then their interpretation is like they don't say that, oh yeah, they don't discard it on the face of it due to air margin. They say that the Earth's orbital velocity, if they were to take the results at face value, would have to be much slower, right? So like they weren't concerned with air margin, like with it being out of the air tolerance, But yeah,
Dude,
Yeah,
if you think about it, go ahead, sir.
Oh, I was just about to say, yeah. Well, the whole thing, the reason why it was so crucial that I find at least that quote. I think I have another one too. I'll have to find the other one as well. But the reason why it was so crucial to me that I found those quotes was because of the error margin argument, right? The fact that like, oh, those fringe shifts that was like kind of my main point in bringing up Michelson-Morley was like, hey, look, these interferometry experiments did detect fringe shifts, which right there on the face of it falsifies relativity, as per Einstein himself, who said that if you could prove that the shifts were anything other than instrumental error, then they would be evidence against relativity, and that's why they hired Shanklin to go and basically ruin Miller's reputation and try to sabotage anybody's view of his work. But it was very important to me that I find out what the error margins was. That's why I was so glad to find that quote, because the fringe shifts that were reportedly detected by Elias were up to like 8 kilometers a second, 7 kilometers a second, or something. Or sorry, not 8 or 7. It was what were they? Well, it was well above that. It was well above. It was multiple times what the Wolfson quote alluded to them being capable of. So I remember grabbing that quote and latching onto it and be like, there, I have a physicist that is backing what I'm saying, that the instruments were sensitive enough to record the fringe shifts that they did. And here's a physicist basically corroborating what I'm saying with that. So
you think about back then on the fringes of like of interferometry experiments, interferometry engineering and science, like that was not even though they were trying to detect the motion of the earth, like it could not have been that hip of a topic. And you think like how they can control narratives nowadays, man, back then, like I like to think that Miller probably had some buddies, like there was probably like a whole community, like maybe he was even well regarded in his town, like, but internationally, like, there's no reason to think that. I mean, it's so with, I don't know. I don't know a lot about the history of that, but I'm just saying from my point of view, back then, it's so easy to control a narrative, especially a narrative in the scientific community.
oh yeah, well, even more easy is to control what our perception of their perception of it was back then today.
Oh
If you
yeah,
get what I'm saying.
well said, well said. Yeah. They wrote the history, so even if people were all like shaking their fists, like, no, that's not what's happening. It's just like they're like, okay, well, fine by us. We just gotta let it wash away in 100 years or something.
Yeah, I'll ponder this real quick.
Exactly. Yeah. Exactly.
When they were talking about putting the apparatus in. Okay, to me, and tell me if I'm off here. To me, they are stuck either way they look at it. Just this linear measurement has got them pinned down, because you got two possible outcomes. Let's say if they put the lab in the back of a truck and they send it down the road and it measures the absolute motion. Well, obviously they're screwed because it's showing the absolute motion. So no matter what repertoire you put it in, it's detecting that motion relative to the ground or whatever he was saying. But then, even if it doesn't detect the lab motion with the truck, like Mickelson Morley, they're claiming, then they'd have to double transform it, right? I mean, am I missing? Like they would have to apply a freaking like a Lorentz transform and a Allen transform or something new to describe that. Why it's measuring absolute motion. It's just crazy, man. I think they're pinned down by this patent. Any way you look at it.
Agreed.
Yeah, the Wang. That's why the Wang one is so important, is because literally their only cope, or why sagnac and RLG, why those could measure rotational velocity. Their only cope was to just assert, baselessly, in my opinion, assert that, oh well, relativity is okay with rotational velocity being measured, but just not linear velocity. And so along comes Wang, and he's like, "Oh yeah, well let's use that very technology, the sagnac technology, FOBGs in this case. Let's use those, and let's move them linearly, and let's see if that linear motion is detected." And surprise, surprise, it's detected. So you're right, Brian, that like, yeah, they're screwed either way in this case with Wang. That's why this is such a monumental find by us.
Yeah, and then he said that like you'd have to put a filament. I'm shocked he even brought up putting it in a truck, the lab in a truck like that. To me, if he'd have thought that through, I wish he did. That's what pinned him down on the absolute part, and he would have took that back. He'd have never even mentioned that, but he did. The cat's out the bag, in my opinion. It's got to have him thinking. But then he mentioned not long after that, like you'd have to put the fiber on, or the filament on the sun. And it's another thing he's gonna, if he watches back or thinks about it, like, what are you talking about? Why would the filament have to be on the sun? It just contradicts everything else that he said if he stops and thinks about it, man.
Yeah, I mean, that's why I kind of me and Alan were kind of just trying to like leave it at like, philosophical impasse. Let's see if we can move on because yeah.
Dude, he wanted blood. Dog, like over a philosophical impasse, like just at the level we were willing to leave it at without even getting into is the satellite orbiting the Earth or is the Earth orbiting the satellite, you know? And it's like
Yo.
dude was demanding blood over like dude, like it's like relax, dog. Like sit have a seat. We're staying in the lab frame. So
That's so
Yeah, that's
crazy. Yeah, like from that perspective. Oh, yeah, sorry. Go ahead, Tris.
Oh, I was just gonna say really quick, like the really ironic part of that, and from an outsider looking into that with seeing you guys, was that you guys came in with a viewpoint, a perspective that was empirically substantiated, as admitted by him outright. He said that it was a viable interpretation, a valid interpretation of the Sagnac effect was C plus V. He said that. You can like rewind it and watch it. So
Yeah,
and then he
go ahead.
and then he claimed that, okay, but in addition to that, look, here's my empirically unsubstantiated, based on nothing but abstract math equations, relativistic viewpoint of that. And then by the end of it, he wanted you guys to concede that his interpretation was right, despite the fact that you guys were the only ones, by his own admission, with an interpretation that was empirically substantive. So like it was nonsense,
So yeah, I agree with all that. I will say, yeah, that's definitely how I see it as well. But I will also say we should probably, just out of respect for Matt, just because he's not here to defend his position,
true.
we should probably just try to keep it to the subject matter.
Yeah.
Good looks, man. That's a good point, man. And I will say this, man. There's not a lot of people that would be able to step into that arena and be able to hold themselves. He does that consistently with you guys, where he's willing to step up to the plate. And at the end of the day, it was 2v1. So again, you're right, Toby.
Yeah,
Thanks for bringing it back to
yeah,
a
it
real.
was 2v1
You're
as
right.
well. That's true. It's also true.
It's true.
So yeah,
right.
I much respect for him, and I think the only reason he brought us both back on again was because it felt like the proper, complete way to do it, since he had us both on, and that was what brought him into the paper. I don't know if we'll keep doing that way. I mean, I would be happy to, but we'll see what happens.
Yeah, it was on all said and done. You know what I mean? Disagreements are bound to happen, and at the end of the day, you guys both walked away with, it did get a little heated, but like Alan said, when you have a disagreement like that, of course, every once in a while it's going to get heated. Like with Whitsitt and Rob Parks, when they had their first, in the field podcast, it got a little heated there as well. But look at them; they were able to show up to debate aspects of astronomy that they disagreed with and be cordial with one another. So of course, I think that's kind of a similar situation to you guys, and I can science that, which we need that open discourse with respectful people,
Yeah, agreed.
Absolutely.
So yeah, should we finally hit this paper up?
Yep. So we're gonna get into the continuation of an experiment that may or may not be remarkable. Some say it's a landmark. Some say it's unremarkable. I'll let you guys be the judge. We're gonna go out here. Yeah, not yet. So let's see here. So abstract. So this is Bennett's summary that he wrote on the Wang experiment and an experiment called DeForeign Pruner, which, as we come to the DeForeign Pruner in the paper, I'll kind of give a quick rendition of it to catch us all up to speed. But it's more more sagnac stuff. It's pretty much the same. Once you get the sagnac, that's it. So abstract. The belief that the sagnac test of 1913 only applied to rotational motion was discounted when Ruyang Wang found the same results of linear motion in 2004. The sagnac result has never been credibly explained despite its wide application in modern technology. In turn, the Wang paper has been virtually ignored in the last 10 years, but remedied by this paper, which establishes the test as a critical signal of striking new concepts. Kinematic and dynamic motion are carefully distinguished here and the neglected topic of covariance is reviewed and applied to the Galilean dynamic law of velocity addition. Analysis of Wang's results of the conveyor and the lab frame with the premise of an ether drag logically leads to the identification of a preferred motion in absolute frame of reference in an earth-bound frame laboratory. So, natural interpretation with the bucket and all this, the stationary lab frame, right? The Earth isn't moving because when you broad spectrum, or like when you picture the overall spectrum of the implications here, Michelson-Morley is out the window. There's no orbital velocity, so the Earth is also stationary in that, right? So that's kind of what he's getting at with this. The light. The speed of light in the lab frame will be the same as for the conveyor, is a testable prediction of this paper, and the same for the Dufour and Prunet test. Discovery of an absolute lab frame and a flexible ether, the alpha model, refutes general relativity and its alleged consequences, such as both postulates of special relativity, general covariance, and general relativity, Lorentz transformations, Minkowski spacetime, length contraction, and time dilation, all disproven by alpha via the Wang and Sagnac test. How could it possibly be that the
absolute lab frame, and then is it ether, right? Absolute lab frame.
Absolute lab flexible ether.
Thank you. Absolute lab flexible ether. Thank you.
Yep. So, introduction. The foundation of the analysis is philosophical realism and the scientific method. So this is a cool thing that Bennett lays out on a lot of his stuff. I noticed he'll tell you like where he's like what method he's using to approach it. So if you want to take a look at his work and then analyze it against the core fundamentals of this philosophy and the scientific method, you could look for contradictions in that regard. And, it's very, very nice of him to include that. So realism forms the basic worldview that is presented here for the required basic and is required for the basic word communication. It is described here in detail. The scientific method of Bacon includes testing hypothesis within equivalent environments, a condition more breached than observed in modern physics. Velocity types: kinematic, experimental test of Galilean relativity are dynamic tests of mainstream predictions for relative velocity addition. In kinematics, the velocity of motion is a description of a measurement. Vcan equals delta x over delta t. So the change in distance over the change in time. Let's see. It is an abstraction having no link to the real world. By pure reasoning, the principle of relative motion can be asserted for two frames in relative motion. So Vcan can be equal to AB, and then you can also say that Vcan AB is receding away from that frame, right? So like kind of that same situation where is the Earth rotating away? Is the satellite orbiting the Earth, or is the Earth orbiting the satellite, right? So same expression. So this is a truism that relates to a separate frame of reference and makes no prediction about the future motion of either frame. So very interesting distinction there about kinematics in regards to measurements and what they do with them kinematically. Lagrangian dynamics, by contrast, in dynamics, the classical laws of motion on Earth are derived from the Lagrangian variation principle. These laws in mechanics and electromagnetism make predictions about motion based on forces on charged masses. These derived dynamic motions, v-dyne xt, so distance and time in this coordinate system, are compared to test or compared to data test V test XT to confirm the validity of the physical laws. For example, the simplest form of L equals T minus V is the kinematic form of motion. T equals mv squared over 2. For this, the L Lagrangian equation equals ma equals 0, where v dyne equals constant equals v. The two reference frames AB would differ by VAB equals V sub A, or no, I'm sorry, VA minus VB equals V, or VA equals VB plus V. Of course, this is the simplest possible dynamic. Of course, the simplest possible dynamics is just Galilean law of velocity addition for inertial frames. What is important to note that the Lagrangian method is mathematical in its use of generalized coordinates. This is called frame indifference. All observers in all frames will obtain the same dynamic laws. Frame indifference, or otherwise known as covariance, is an assumption to be proven or disproven by experimentation. So this is a huge important thing here. So if you were to invoke a new a reference frame transformation or something like that, it's like, okay, cool, but that's just a hypothesis awaiting to be, substantiated by experimentation. Although the Lagrangian method uses the same generic coordinate system, the laboratory reference frame is the only one in which dynamics predicted by the Lagrangian can be validated by experiment. The lab frame is the only reference frame proven to be covariant in regards to the dynamic law, where dynamic laws are valid. Any questions so far?
No. You want me to take over reading for a minute?
Yeah.
Cool. So the initial testing of mechanics and electrodynamics was done in laboratories fixed to the ground, mainly by Galileo and Newton, Faraday and Maxwell, and of course, many others. Mechanical dynamics is covariant under a Galilean transformation, but electrodynamics, Maxwell's laws, are not. That's a good point, or an interesting point. Okay. Einstein tried to resolve the lack of covariance between the two law sets by using Lorentz transformation in electrodynamics, a mistake. Maxwell had assumed the ether to be immovable, a solid, but Hertz generalized the partial time derivative of Maxwell's laws to include a convection term for fluid motion of the ether, a total time derivative of the EM fields. A new variable is introduced thereby, the velocity of the ether frame to the lab observer's frame. This extension of Maxwell's laws is now Galilean covariant, as is Newtonian mechanics. We will call this extension the Maxwell-Hertz laws of electromagnetism. So let's just note here, Hertz is generalized the partial time derivative in Maxwell's laws to include a convective term for fluid motion. This new term brings covariances to dynamics and electrodynamics. Okay.
Yeah. So that's actually what Bennett was talking about before he dipped out. So it's cool that we just got to that. So yeah, that term merging those two. So the distinction there is if you need the speed of light to be the same in all reference frames, well, you're going to hit up your boy Lorentz, and that's where you're going to get into unverifiable, untestable kinematic nonsense. Now, what you have with Maxwell's equations and Galilean velocity addition being covariant with Newtonian mechanics, you have real applicable tests in laws of motion that can be explained through, meaningful in a meaningful way rather than abstractions with no regard to anything. And this is all based on the fact that they didn't want to accept that the Earth isn't moving.
Yeah.
So they have a perfect framework here to describe reality, but they're like, no, separate these two interferometers and use a Lorentz transformation to explain one of them.
Yeah, and just to kind of add to that, it was Fitzgerald who had suggested originally, and this was the explanation that had literally been dreamed up specifically to address the negative result in the Michelson-Morley experiment. And Fitzgerald in 1893 had suggested that objects contracted their motion through the ether. So the ether was still part of the framework at this point. And they were the original theory had to do with, well, objects flattening out upon impact with the ether. So that was what shot off all of this, the Lorentz Fitzgerald transform equation, the contraction of matter, was because it was theorized that matter moving through the ether would hit against the ether and the matter itself would contract. And there was massive issues with this, such as the issue that like matter is made up of all different types of material. So like you have like iron and wood and like plastics, and they're all contracting at the same amount. So this was proposed by multiple physicists at the time as issues with this theory, where they were like, oh, okay, well, if objects are contracting due to the ether, well, wouldn't objects made of different compositions and different materials contract at different rates? And it's like, yeah, it would, and that was literally not addressed at all. That went completely unanswered, and then they did away with the ether altogether. And then you have like the modern interpretations, but the original interpretations had to do with, I believe that's what he's alluding to right there, which is where he said Einstein tried to resolve the lack of covariance between the two law sets by using the Lorentz transform in electrodynamics, a mistake Maxwell had assumed the ether to be immovable, a solid. Well, that was literally what they had done originally when they proposed the cope for the Michelson-Morley results, solid ether in which objects contracted against. Just to add to that.
Cool. Yeah, good stuff.
Thank you.
So moving on, or what, Alan?
I said thank you.
Yeah, thank you. So moving on. However, the laws of dynamics were not tested formally and rigorously for Galilean or inertial covariance in any other reference frames moving relative to the lab until Fizeau, Sagnac, and Wang. No formal tests of dynamic covariance were done in cars, trains, planes, spacecraft, nor on the sun, moon, or a planet. Pardon me. That's a really, yeah, I see why you highlighted that in red. Since it is known that the laws of dynamics are valid in the lab frame, that is, the lab frame is covariant, we can use the dynamic law of velocity addition to establish useful relations between frames A and B for testing by Wang. V, A, B equals VA minus VB equals V. If A equals B, V times A, V, what is that meaning? Is that like what is that denoting, the comma there?
I couldn't tell you. It's just different coordinate systems, I guess.
Okay. Equals VA minus VA equals 0. For any frame X, the identity axiom is true. VX X equals 0. From VA equals VB plus V, with A equals lab frame and B equals N lab, any non-lab frame, V lab equals VN lab plus V. Okay. Finally, for an object at rest, dynamic laws are valid in the lab frame if the equations of motion use V rest object lab equals 0. Measured. A third type of motion is VMEAS, the experimentally determined motion using the kinematic definition of velocity V equals dx over dt. A central issue in the Wang FOC test is the discernment whether V measure equals V dynamic. Do the dynamic laws agree with reality for all observers in all reference frames? Covariance in dynamics means that measurements in a reference frame satisfy the laws of physical motion for mechanics and electromagnetism, the laws of Newton and Maxwell. The first postulate of special relativity asserts that inertial frames, like the linear conveyor, are covariant. Frames accelerated relative to the conveyor would not be covariant in special relativity. The Wang experiment not only tests for whether the speed of light, Sagnac result, speed of light equals c plus or minus v, and rotating bodies also holds true for linear motion. It also tests if ether outside a moving body is co-moving with the body, as Sagnac surmised. Fizeau had already found that ether is dragged inside a moving object at a lesser speed, supporting the drag equation for speed of light in a moving fluid, Fresnel drag. Speed of light equals c over n plus v, times 1 minus 1 over n squared. And n in that equation is...
Refractive index.
Okay. Perfect. Okay, cool. Tested also is whether the conveyor frame is covariant. Does V measure in the conveyor frame equal the prediction of the laws of dynamics? V din as the conveyor moves linearly relative to the lab frame. Does V measure in the conveyor frame? Okay. The world of kinematics is abstract and symbolic. The world of dynamics is concrete and empirically based. It will be important to distinguish these concepts in the following analysis. Wang fiber optic conveyor. The results of the Sagnac experiment of 1913 were interpreted by Sagnac as disproving the second postulate of special relativity for constant speed of light equals c, and establishing the existence of co-rotating ether whirlpools around spinning objects. The condition for co-moving rotor and ether is v ether rotor equals 0. It was assumed that the Sagnac results only applied to the rotational dragging of ether, but 91 years later, in 2004, Wang showed the same result is found when ether is dragged in a straight line by a mass in linear motion. Sagnac setup is improved by using fiber optics instead of mirrors to form the optical path and amplify the timing difference by using multiple coils. The fiber optic gyro, FOG, figure 1 on top, then the loops are distorted into a racetrack oval to create linear sections, figure 1 bottom. Linear motion will not affect the phase shifts of the circular sections, so any recorded effect is due to the linear motion of the linear fiber optic cable. Pretty straightforward, okay? In figure 2, the bold line is the optical path / fiber, which corresponds to the fiber optic path in figure 1. The light diagonal line is the conveyor cord. The fiber optic gyro interferometer is mounted on a conveyor and records the change in speed of light as the system moves linearly with speed v in the lab frame. Just as the Sagnac test, a light beam is split and the two half beams are sent in opposite direction through the linear segments. The FOG has the same speed as the conveyor. Figure 3 shows the physical layout. The fiber optic cable wrapped around the two wheels moving at the same speed as the conveyor. The bottom fiber optic cable is moving to the left, so it drags ether to the left at V. The top fiber optic cable is moving to the right, so it drags ether to the right at V. According to Sagnac's interpretation, in this way, the light beam direction is always with the ether direction or always opposite. In neither half beam does the ether speed cancel on a round trip of the beam. Clever. In neither half beam does the ether speed cancel on a round trip to the beam, or round trip of the beam. Interesting. So there's a picture of it. We've seen that a bunch, that's for sure. Conveyor frame analysis. The FOG is only needed to provide the source and detector, beam splitter, and condenser. Only needed to provide the source and detector. Okay. And as the FOG will not detect phase shifts with any linear motion. Figure 4 shows the essentials of the test equipment. The arrows indicate the motion of both fiber optic cable and the ether entrained by the motion of the wheels and cable. Wang took light speed measurements in the conveyor frame, speed of light con, where fiber optic conveyor is at rest and the lab frame is moving at negative V, and found the results graphically displayed in figure 5. Phase shift is proportional to optical path length and conveyor speed in the conveyor frame. Which frame? The conveyor frame.
Dude, so this was super, super important, man. And my bad for not jumping on it towards the end, but I just wanted super out. But the frame is determined where the detector is. So when he was talking about, well, I'm interpreting it from my face or whatever. It's like, well, no, the measurement is done in the lab, or I mean, sorry, is determined by where the detector is. So
Yeah,
the
that's
detector,
that's
the
the concise
detector is
way to put
on
it.
the conveyor in frame.
Yep. Yep.
So
That's how we should have put it. Because
so
that's the concise wrap up. Yeah. Continue.
yeah, so that's a huge. This is like the most important part.
I would agree, especially especially given the nature of the conversation that we had earlier. Yeah.
Yep.
For a fixed length of fiber, the graph shows that when the conveyor is at rest, speed of light con equals c. Okay, so you shine the light, or you run the laser through the gyro or through the fiber without any motion, you get the speed of light. The linear relationship between phase shift and speed means that phase shift is around the same as v. Speed of light con is measured as a linear function of v. Speed of light con equals c plus or minus, c plus or minus v. So he's showing. Okay. In any case,
Dude, we should have read this before we did that.
right.
Just to brush up on it, but yeah, it's like
Yeah.
it's pretty straightforward. So relativity predicts that the linear motion of the observer in the conveyor in linear motion predicts no variance in c. But what do we measure? Variance in c proportional to the velocity, approximately. Right.
Yep. All right. So where the plus holds for co-moving light beam traveling in the same direction as V, the minus for the counter-moving light beam traveling in the opposite direction as V. A result that corresponds exactly to the Sagnac result. Yep. The speed of light decreases with the speed of ether it propagates in, just as a rowboat moves faster downstream in a river than in a lake. Well said, Mr. Bennett. Well said. Like that old, like you're taking a rowboat down that old absolute space that happens to have a flow to it. Okay. The last equation is an example of velocity addition in inertial frames. The Galilean law of relative motion applied to the motion of light and ether. Lab frame analysis. Wang did not. Dude, Bennett, shout out. What a G. Wang did not mount the FOC interferometer in the lab frame and measure speed of light lab with the conveyor again moving as various speeds, but neither did Sagnac. However, Dufour and Prunier repeated the Sagnac experiment and did speed of light lab with the interferometer at rest in the lab next to the rotor. They found the same result in the lab frame as in the conveyor frame. Speed of light lab equals speed of light conveyor equals C plus V for the co-moving beam. Speed of light is not C in either frame, but is C plus or minus V in both frames. This is consistent with Sagnac's belief that the matter in motion drags ether along at the same speed, which causes the observed change in speed of light. The lab frame, the speed of the conveyor, Vcon, drags along the ether at speed VAE. So, like, I want to pause here because for me, like, this is like going back to what I thought about physics a year ago, maybe a year and a half ago. I would have thought that time and space have to warp around C, right? And so anything that you would measure, like you could try and make an argument that if you're measuring from within the rotating disc, that you are just, no matter how you measure it, you're just measuring an apparent contraction or an apparent speed based on your own contraction, right? Or your own however your own reference frame was warped around the speed of light. So what this is showing is that it's not just like the measurement is being the motion is occurring, and then the measurement itself, it's being measured outside of the rotating disc. So it's the same light. That light was then
propagated out of the rotating disc, and when it's propagated out of the rotating disc, the fringe shift is still there. So it's not just an apparent thing. It's not just happening in that frame. It's the universal truth of what's happening. The speed of light is going faster or slower with the ether. And to me, like that's to me, this is awesome. Like this is like just for me personally reading this, I lose cognitive dissonance. Like this is amazing. So in any case, if the conveyor and ether are co-moving at V in the lab frame, then the ether must be stationary in the conveyor frame. Conveyor frame VAE con equals 0. Now, Wang did not record the speed of light in the lab frame. He had repeated his conveyor test Wang did not record the speed of light in the lab frame. Had he repeated his conveyor test in the lab frame by putting all the optical apparatus at rest on the lab table next to the... Scroll down, please.
Oh, shit. Sorry.
Next to the running conveyor belt, then the moving conveyor would drag the ether as before, producing the same results as in the sagnac test, the rotating case, namely speed of light lab equals speed of light con equals C plus V for the co-moving beam. It seems Einstein was correct in one respect. The speed of light is constant in all frames, but not equal to C. Speed of light is constant in all frames, but not equal. Yeah. Okay. Wow, it's funny when things are just sensible. Okay. The speed of light is the same as measured in the lab frame in all frames. From here forward, we will analyze the co-moving half beam. The counter-moving half beam is similar. So, yeah, in all frames. So if you're in an inertial frame that's relative to that speed of light, the speed of light you see is going. The difference here being is that you're actually dynamically in motion with the speed of light, and you're not just seeing some relative nonsense. Okay, prediction. Speed of light lab equals C plus V. It is my prediction for a future Wang test in the lab frame.
So
it
wait,
is based on...
Wait,
so
what? You're
wait,
telling
I
me
say
that...
something wrong?
No. So you're telling me that there's no principle of relative simultaneity? That there's a cohesive chain of events?
Dude,
You're telling me that
so beautiful.
like,
Who would have
dude,
thought that our reality is just sensible and cool?
Man. So,
Blasphemy.
Not full of relativistic, like... Oh boy, yeah.
Yeah, sorry. I was just thinking about that. It's like that's the whole reason they're like, oh, the principle of relative simultaneity that's not included in GPS corrections. It's like I wonder why. Oh, there's a cohesive timeline where C is constant, but not in all. It is not equal to C in all frames. Cool.
Yeah. So speed of light lab equals C plus V is my prediction for a future Wang test in the lab frame. It is based on compliance with the same result in the sagnac test, ether drag as analyzed in both frames. It provides an experimental test of the ether drag premise. The graph of phase shift versus speed in figure 5 applies to the conveyor frame, but the speed of light in the lab frame is the same. Speed of light lab equals speed of light conveyor equals C plus V. So the graph in figure 5 can be used for both lab and conveyor frames. Note, Dr. Wang could not be convinced to repeat the FOC test in the lab frame or to repeat the linear motion in different horizontal and vertical directions, so to confirm the isotropy of the result. What a G you are, Robert. Do you want to take over, Alan?
Yep. All right. Analyzing the conveyor frame, a stunning result. Going unnoticed by Wang and many others is the outstanding evidence in this experiment of the dynamically motionless Earth. To see this, recall that the dynamic law of Galilean velocity addition is presumed to be valid in all reference frames if the principle of general covariance is true. Galilean velocity addition has been tested in the lab frame for covariance and has been found to be so. The conveyor frame is in constant linear motion compared to the lab frame. As Sagnac did for rotation, Wang has tested the motion of translation for covariance. The dynamic law of velocity addition in the conveyor frame is The speed of light conveyor equals pH ether plus V ether conveyor plus C, or I'm sorry, equals C plus V ether conveyor. And from Wang's results measure, the speed of light conveyor equals C plus V. That implies that V ether conveyor frame equals V of the equals V the conveyor frame conclusion. But the lab frame analysis found that V ether con equals 0, the lab frame conclusion. If the conveyor moves with the speed of V in the lab frame, V con lab equals V, and the ether is dragged along the conveyor with the same speed, V ether lab equals V, then the ether must be co-moving with the conveyor, and if the conveyor is a valid frame of reference, then the ether must be co-moving with the conveyor if the conveyor is a valid frame of reference. But measurement, the ultimate decision maker, says that the conveyor is a valid frame of reference, then it should be true. So the speed of light conveyor equals C plus V ether conveyor equals C plus 0 equals C. But the Wang fiber optic conveyor result is the speed of light conveyor equals C plus V ether conveyor equals C plus V. The conveyor frame dynamics are not covariant because because they disagree with the validated lab frame dynamics. Conclusion: the conveyor frame is an invalid reference frame. The result is quite general. The conveyor frame, or the conveyor stands for the ether. The result is quite general. The conveyor stands for any ether dragging mass moving relative to the frame. But what is the correct dynamics when not in the lab frame, in the conveyor frame? And what and what can cause V ether conveyor to equal V of the conveyor frame instead of 0? Comparison: the speed of light measured in the lab frame, or in the lab in conveyor frames. The speed of light lab equals C plus V. The speed of light conveyor frame equals C plus V. This seems to indicate that the lab value of the ether speed, V ether lab, replaces the conveyor value of V ether con, or a conveyor. The dynamic law found by the Lagrangian analysis prefers that the lab values over the conveyor values. The inference is really stronger than just a preference. The conveyor frame dynamical law absolutely must use lab values over conveyor values to agree with experimental results. In other words, the lab frame is the absolute reference frame in which to apply the laws of dynamics.
Dude. Yeah, that kind of was. Oh, dude. Yeah, this is good. You're right. We totally should. We should have read this last night.
Yeah.
Well, yeah, easy to say now.
Yeah. It's all good. Yeah, dude, it was easy to say now after we read fucking 30 papers last night.
Right.
Kinematics versus dynamics. Okay, so this is a big distinction here. So remember, we have measurements and we have predictions of motion based on the measurements using the laws of physics. So the kinematic law of relative motion, kinematic VAB kin VAB times T is equal to V kin V. So basically, am I moving away from you, or are you moving away from me? Who can tell is always true. So this is kinematic laws of motion. The dynamic relative motion law is that dynamic lab frame. In the same situation, one of us is moving and the other one's not. We both can't be moving away from one another, practically, right? So for example, VLab implies, so like in that regard, like in the terms, if you were going to look at it from like Bennett's Hitchhiker, for example, that's a really easy one. Stationary guy on the side of the road, guy in a car, who's really moving, right? Kinematically, you could say the guy on the side of the road is moving towards the car at the same, speed or whatever velocity that the car would be moving from, right? But in reality, the guy on the road's stationary, like we all agree. So that's kind of what he's saying here for the distinctions. For example, V lab con implies that V lab and N lab equals 0 in any law of physical motion dynamics, the N lab, and any non lab frame. This does not mean that V lab, N lab will be measured as 0 as the measurements are kinematic, not dynamic. In fact, that would violate the axiom of kinematics, which is kin VA B minus, so just the relationship with the relative motion. The principle of relative motion, which is always true, but that says nothing about future motion as dynamics goes. Confusion is a guarantee if one doesn't discern definitions and descriptors of motion in kinematics. From predictions of future motion, Lagrangian dynamics. So you're going to get really confused if one doesn't discern the definitions and descriptors of motion as kinematics from the predictive motions, from the predictive future motions using Lagrangian dynamics. Let's see. In B, from here forward, kinematic is V, or kinematic V is designated with a K prefix. So KV is kinematic V, and with no prefix, V is dynamic velocity. So V equals V or dynveen and kinveen, right? So we got kinematics and we got dynamics here. So we will now examine the consequence of an absolute lab frame to establish logical consistency, keeping in mind that the lab frame must always be used in dynamics as a consequence of the fiber optic gyro or fiber optic conveyor and Wang sagnac result. Dude, I had literally almost said it. The Wagnac. Actually, that's actually what it is now. You know, the Wagnac effect, bro. The Wagnac. So V ether con uses V ether lab, and in dynamic laws, V ether con equals V equals lab equals V, where V in this equation is the absolute the absolute speed, the only value that can be used in dynamics. V lab equals VA. So V lab, V lab conveyor uses V lab equals 0 in dynamic laws. V lab, conveyor time equals 0. When applying the dynamics of the conveyor frame, the lab speed is always 0. This reconfirms that the lab frame is always at rest according to the dynamic laws of physics.
When applying the law of dynamics in the conveyor frame, the lab speed is always 0. Okay, cool.
All right, let's reinforce this concept in the lab frame. V ether lab frame equals V. When measured and applying the laws of dynamics, in this case, Galilean velocity addition, this is measure ether lab equals dynamic. Damn, this gets so confusing. Dynamic V ether lab frame equals V. For the conveyor frame, dynamic V ether conveyor frame equals V. When measured using the same dynamic laws of physics, Galilean velocity addition, but dyn V ether conveyor should be 0 to be consistent with the lab frame results. V ether conveyor equals V ether lab plus V lab conveyor. V equals V plus V lab conveyor. V lab conveyor equals 0. And VCon lab equals...
Not equal to VCon lab equals V.
Not equals to VCon lab. I'm sorry.
Want me to take over?
Yeah.
Cool. When applying the same law of dynamics, again, only the lab frame is covariant. Only the lab frame is covariant. Okay. Yeah. Okay. The lab frame graph where the origin clearly displays the 0 speed of the conveyor in the lab frame when the contemporary interpreters of dynamics have the Earth rushing in various directions around the Sun and Milky Way center toward the Virgo cluster, etc. Wang test conclusion. The absolute lab frame fixed ether model is not restricted only to photons and rotating ether, but also holds for ether in linear motion, that is, all ether motions. V lab, N lab, must be set equal to 0 in dynamical tests for them to be valid, equal to covariant. There are no restrictions. However, on the measurement of VLab NLab, there are no restrictions, however, on the measurement of VLab NLab. Speed of light equals C plus V is valid. 1, for the co-moving beam in the Wang test. 2, for the co-rotating beam in the sagnac test. 3, in the lab and conveyor and rotor frames. 4, independent of source and detector motion. 5, but dependent on ether motion, that old absolute lab frame. So
Yep. Give me 1 second.
the conveyor is a specific case of any reference frame moving relative to the lab, a NLab frame. We are justified here in generalizing conveyor frame assertions into NLab frames, since all mass and motion will entrain a co-moving ether. Premises/axioms. Assumptions in metaphysics that are self-evident and falsifiable, yet not falsified. The Lagrangian derivation of dynamics assumes general covariance/frame indifference. Principle of general covariance. The laws of dynamics are valid in all reference frames. The lab frame is the only reference frame known to be covariant. Dynamical laws are valid. Speed of light, or light speed in the ether frame, ether is at rest, is always C, the vacuum value. VPH AE equals speed of light, ether equals C, where pH represents the photon frame, ether is the ether frame. Ether drag axiom. Velocity ether lab equals velocity object lab. Ether near a moving object is dragged or entrained to co-move with the object. The conveyor speed is VCon lab equals V. The conveyor frame has a co-moving ether, implying the ether is at rest in the conveyor frame. Kinematic velocity ether lab equals V. Kinematic velocity ether conveyor equals 0. The kinematic law of relative motion, kinematic velocity AB times T time equals kinematic velocity BA times time. No frame moving relative to the lab frame, non-lab frame, has ever been formally and rigorously tested and validated for covariance. Galilean relativity axiom of dynamics, VAB equals VAC plus VCB. A, B, C are inertial frames. Identity axiom, Vxx equals 0. Measurements, velocity addition, V, pH con equals sol con equals C plus or minus V, co-moving half beam. Conveyor speed, V conveyor lab equals V. Ether speed in the conveyor frame, V velocity ether conveyor equals V. Prediction. By analogy, with the Dufour-Prunier result, speed of light lab equals C plus V. According to relativity, if ether and conveyor are co-moving, velocity ether conveyor equals 0. I'm trying to just like
Yeah.
relativity. If ether and are co-moving, yeah, okay.
Yeah, because
Theorem
there
slash
wouldn't be
laws.
any relative motion, right?
Yeah, because I'm just like, it's funny to hear ether used in context of relativity. It like threw me, like my brain was like, wait, what? Okay. Theorem slash laws. Laws are derived from the premises and test data. The principle, I'll go back up a little bit.
Oh, sorry.
You're good. The principle of absolute covariance. The laws of dynamics are valid only in the lab/Earth reference frame. Replaces the principle of general covariance.
Oh, I like absolute covariance. That's a good.
Doesn't it just feel good on
feel-
your brain?
It feels a lot better than general covariance.
It does. It makes covariance sound sensible. An absolute or an object is at rest if its lab frame's speed is 0, velocity object lab equals 0. If the conveyor is a valid frame of reference, velocity ether conveyor equals 0, but measurement says that velocity ether conveyor equals V. The conveyor frame dynamics are not covariant because they disagree with the validated lab frame dynamics. Conclusion: the conveyor frame is an invalid reference frame. Dynamic relative motion. Dynamic velocity ABT is greater than or equal to negative dynamic velocity BAT. Only true if A equals B equals lab frame. Absolute rest or geostatic absolution law. Dynamic VLab and lab time equals 0. The lab frame is always dynamically at rest, like the Earth is not moving or something. In the lab frame, measure velocity ether lab equals dynamic velocity ether lab. In the conveyor frame, measured velocity ether conveyor equals dynamic velocity ether conveyor. Well said. Absolute frame substitution. Velocity xy is equal or greater to velocity x lab. Absolute velocity addition. Vx lab equals Vxb plus Vb lab equals V plus VB lab. Specifically, the speed of light in any... Went down a little far.
Oh, sorry.
One line up. There we go. Specifically, speed of light in any reference frame is... reference frame X is speed of light X equals V pH ether plus V ether lab equals C plus velocity ether lab. Light speed only depends on the ether speed in the lab frame. Light speed dude. That one, yeah. Put that one on a t-shirt. The alpha model. Dude, this paper is loaded. Alpha is an acronym for Absolute Lab Frame Flexible Ether. All predictions of this model are based on absolute AL. The lab frame is the absolute preferred required frame for applying the laws of motion. The Earth is always dynamically at rest. I'm going to read that again. The lab frame is the absolute preferred required frame for applying the laws of motion. The Earth is always dynamically at rest. FA. The primitive substance of the ether that fills all space can be forced to move, flexibility, by mass in motion through it. Flexible ether. Okay, yeah. The principal axioms of the alpha absolute lab flexible ether model are: ether is flexible, either dragged by matter or having natural autonomous motion. Dynamic laws must be in the lab. Earth-centered, Earth-fixed frame. Speed of light x equals c plus velocity ether lab. Alpha application. The fluid model of ether and its ubiquity lead to a reconsideration of the fundamental Lagrangian derivation of the dynamic laws of physics. If ether is everywhere, a universal continuum, then the Lagrangian approach has to be modified to include the energy contribution of ether in free space. Free ether containing no particles, aka the physical vacuum. The mechanical models of mass particles, either as extended or as points, must also be replaced by bound states of ether. In this sense, ether unifies physics by providing the single substance from which all reality is formed. The prime matter of scholastic philosophy is given thereby a scientific breath of life. Unfortunately, research into ethereal properties has been bypassed for the last century by the relativistic wrong turn in 1905. To derive the measured speed of ether in the lab frame, V ether lab, the Lagrangian must have a kinetic energy term for ether, TATIJ, AIJ, being a general tensor field representing the contribution of free ether. In general, the Lagrangian must have additional terms for ether kinetic and potential energy, as well as the particle model energy based on mass. LMA equals TM minus VM plus TA minus VA. This is a particle field model which usually requires an interaction term that couples the mass to the field. No coupling term is needed because of the universality of ether. The mass energy is due to the stable bound states of the ether, which means all energy is ethereal, either bound or unbound. In other words, the mass term is a derivation from the unbound ether properties. There is no clear and precise boundary. That's very interesting and pretty loaded. Between a particle and the free ether. only a smooth and continuous transition between the two. So the mass m is really an average for the inertial properties of the bound form of ether. M equals ma. The Lagrangian now looks like this. LAB AUB equals TAB minus VAB plus TAUB minus VAUB. AB is the bound ether field, AUB the unbound one. Interesting. On ultimate unification of the laws of dynamics will result when a single ether field, a T at represents both bound and unbound states. LAT equals TAT minus VAT. This is the research program as planned. It will need research into past ether testing and the scheduling of more tests to compensate for time lost while pursuing the failed theory of relativity. The second axiom of absolute covariance requires that all dynamical predictions be based on the laws of dynamics derived from the Lagrangian method as applied in the lab frame. I need to step away for just 1 second if you want to take over, Alan.
Yep, no worries. So instead of, let's see, what was the Lagrangian method applied to the lab frame? Instead of using generalized coordinates in the Lagrangian method, the lab frame must be used for valid predictions in reality, reality being the world measurement. L times L lab, or I'm sorry, A lab equals T, A lab minus V, A lab. Applying the laws of dynamics to non-lab frames. What if an observer's frame of reference is not in the lab and is moving in lab frame and moving relative to the ground? How do we measure? How do we use the measurements of V lab in lab in the laws of dynamics to make the correct predictions of motion on a non-lab frame? The measure of motion in the non-lab frame, velocity, acceleration, etc., turn out to be only phenomenal or apparent, like a stick bent in the water surface. As a sample, consider a car of mass m accelerating past a man of mass m standing on the side of the road. The mass of the accelerating car, the measured acceleration of the car on the road or the man's frame is a car, road equals plus a. The measured acceleration of the car frame is a road car equals minus a car road equals a. This is the kinematic law of relative motion. So again, earlier, like I was saying, is the guy stationary on the side of the road stationary, or is he moving towards the car at the speed that the car is moving and the car stationary, right? The same situation. So Earth frame, the man uses the second law of mechanics to predict that the objects in the car frame will be subjected to the force F car, road equals ma car, road equals ma, which testing confirms. Objects in the moving car, like the passenger, will feel an inertial force equal to their mass times a, or times plus a. The car frame, the second law of mechanics, is used to predict that the man on the road, or what forces that the man on the road will feel or will measure as a force. So F man car equals m a road car equals minus ma, which testing disproves. There is no inertial force on the man or any object outside the car. Measured F man car equals 0, not equal to minus ma. Newton's second law of dynamics is valid in the road or on the Earth lab frame, but not in the car, which is a non-lab frame. This is another dynamic law, like Galilean velocity addition, which is covariant in the Earth frame only, non-lab frame dynamics. We assume that we have the law of Lagrangian derived from dynamics, the LOD, the law of Lagrangian dynamics, which is Lagrangian derived dynamics, which which is a generic function of motion. So just the coordinate system describing motion. X is the reference frame to the massive, or X is the reference frame of a massive object in motion. Y is the observer's reference frame, and R is the coordinate system, R the coordinates, observer's reference frame coordinate. Wait, what am I reading here? X is the reference frame of the massive object in motion, and Y is the observer's reference frame. R, the coordinates. V, the velocity, and A, the acceleration of the reference frame. X observed in the reference frame Y. Only when the lab frame measured, or only when lab frame measurements were substituted into the Lagrangian derived dynamics function, is the function equal to 0. So when X is in any non-lab frame, NL and NL and Y is the lab frame. So we got the equation here for that. So the law of Lagrangian dynamics, NL, comma 1 equals 0. So anticipating further simplification, we break down the dynamic law of function. Or we anticipating the future simplification, we break the dynamic law into a function dependent on position, F position, RNL, comma L, one dependent on the motion descriptors, FMOT. Yeah. Okay, so more equation stuff here to describe the frames and positions and motions, the law of relative motion. So are you coming towards me or am I coming towards you? The dynamic law of geostatic absolutism. So VL, let's see. What was it?
Want me to take back over?
Yeah.
Let's skip to from the law. Let's skip to here.
Yeah.
The laws of dynamics in a non-lab frame only depend on the position of the frame relative to the lab frame. RNL. Example given: the second law in the lab frame would be LOD lab equals F minus MA equals 0. Force minus mass acceleration equals 0. Is that right? Where there is no position dependence in LOD, Lagrangian dynamics, is that right?
Yeah.
Lagrangian, in any lab frame.
So
A lab, N lab,
any non-lab frame. Sorry.
Thank you. Absolute lab, N lab equals 0, and F lab, N lab equals 0. This was shown in the car example above. The road observer detects no force from the accelerating car. Alternative proof that if F, RT, VT, AT equals 0 are the equations of motion derived from a Lagrangian, then they are only valid in the lab frame and not in a non-lab frame. The motion of an object in the lab frame is given by R object, lab T, V object, lab T, A object, lab T, but the observer is in the not lab frame where R object N lab T equals R object lab T plus R lab N lab T, or another variation, be swapping out so I'll just read it. R object lab T equals R object N lab T minus R lab N lab T. If the lab frame motion can be measured by the N lab observer, then this equation for R object lab T can be substituted into the dynamical equations F R lab T, V lab T, A lab T equals 0. Becomes that whole thing. As example, consider Newton's bucket, where the origin of the lab and bucket frame is the bucket center, and the bucket is of radius a, and rotating in the lab frame with angular speed. What is that? That's omega, right? Omega BKT lab equals omega. An object M is located on the bucket wall at R object lab equals A. The dynamic law in the lab frame is F R lab equals 0. So F lab minus M times R object lab times omega object lab squared equals 0 equals F lab minus MA omega squared. As expected, the centripetal force of dynamics is valid in the lab frame. In the bucket frame, from the kinetic law of relative motion, omega lab bucket equals negative omega. So omega object bucket equals omega object lab plus omega object bucket equals omega minus omega equals 0. Let's verify
that the centripetal force law is not true if we just use our object bucket in the bucket equals not lab equals outside of the lab frame. Does FR bucket equals 0? That thing, F bucket minus M times R object bucket times omega object bucket squared equals 0 equals F bucket minus MA 0 squared equal or greater to the F bucket equals 0. False. There is a non-zero centripetal force in the bucket frame. FC equals MA omega squared, the lab frame value. For valid dynamic equations, we must use lab frame values. FR lab equals 0 becomes F R object bucket minus R lab bucket equals F bucket minus M, R object bucket minus R lab bucket, omega lab bucket squared equals 0. F bucket minus MA minus 0 times negative omega squared equals 0, which is going to be equal or greater to F bucket equals MA omega squared in the bucket frame as measured. Measurement of speed in non-lab frames. Let the moon be a specific not lab frame. The moon's orbital speed in the Earth frame is around 27 kilometers per second. The period is 24 hours, 53 minutes. Thus, orbital speed will be detected when a fiber optic gyro apparatus with a linear segment, fiber optic gyro plus L stationary on the moon, is oriented along a lunar latitude, east to west. The FOG plus L will detect the FOG with a linear segment will detect no speed or phase shifts when oriented in the Earth's direction or along a longitude. The FOG, the fiber optic gyro with a linear segment, reads the speed of light in the lab frame. On the moon, the speed of light moon will be c plus v, where v equals 27 kilometers per second. In an LEO space satellite of the FOG with a linear segment will read from 5 to 8 kilometers per second.
In a low Earth orbit satellite.
Thank you. Okay, so I mean, that's pretty cool. Basically, he's just saying you want to measure absolute dynamics. You want to measure, like, this background frame might be a good way to do it.
Yeah.
The answer requires no testing, just rational evaluation of multiple absolute frames. Consider the moon as another absolute covariant reference frame. Like the Earth, in which the laws of dynamics are valid, like the Earth, the moon frame will be at absolute rest. Two covariant dynamical reference frames. From law number 5, absolute rest. VABS x equals 0. And assuming the moon is also an absolute frame of reference, V moon xt equals 0, where x is any non-moon reference frame, including the Earth. Choosing x equals Earth, V moon Earth t equals 0, which is contrary to the observed relative motion of Earth and moon. In brief, Earth and moon are in relative motion, so both can't be at absolute rest. All objects in the universe are in motion relative Earth, so only Earth is at rest. How can the speed of an object in a non-lab frame be greater than 0, but 0 in the laws of dynamics? How can velocity equal 0 and also velocity is more than 0? V can represent different values, so it's crucial to distinguish them correctly. There are 3 types of motion. 1, as described or modeled in kinematics. 2, as predicted by laws or equations of dynamics. 3, as actually measured in reality. So you have kinematic velocity, dynamic velocity, and measured velocity. Well said. The kinematic principle of relative motion is always true. Kinematic velocity is times...
Are you moving towards me or am I falling away from you? Just say that.
Okay, thank you. It's a metaphysical truism, like 2 plus 2 equals 4. We cannot conceive how it could possibly be false. But as a relation between 2 reference frames, it tells us nothing about motion in a single frame. But dynamics does. Why is covariance even necessary? Why not have different dynamic laws for different reference frames, not just the lab frame?
Great question.
The answer lies at the very foundation of science. Its purpose is to unify the complexity of nature into rules that have the broadest application possible. In fact, unification of the current physical laws was the goal of Einstein and modern string theorists. If there were different dynamical laws for each distinct reference frame, then there would be no unification, but chaos. There would be separate laws of motions for cars, trains, planes, spacecraft on the moon and planets, etc. Say it again, Robert. Scientific laws are intended to summarize a large collection of facts or range of phenomena determined by experiment into a single statement. If dynamical laws differ by their state of motion relative to the lab frame, then they are simply facts, not laws. This is pure empiricism. Truth is found only by specific testing. There are no predictions by deduction from general laws. Let's say that again. Truth is found only by specific testing. There are no predictions by deduction from general laws. If covariance does not apply anywhere, then there are no dynamic laws. If covariance does not apply, then there are no dynamic. Okay. If there are no dynamic laws that predict motion, then there is no dynamics as a science. Galileo's ship and relative inertial motion. Galileo's 1632 book, Dialogue Concerning the Two Chief World Systems, proposed the case of a ship moving at constant velocity relative to the shore to show the classical principle of relative velocity. Galileo asserted there is no inertial observation made below deck, i.e., without looking out the window at an external reference. No internal observation made below, okay, by which one can distinguish between a system moving uniformly from one at rest. Back to the old thing, who's moving? Relative motion. Hence, any two systems moving without acceleration are equivalent, and non-accelerated motion is relative. So if you happen to be decelerating in relation to me, it's going to appear as an acceleration in relation to me. The principle was stated only for mechanical motion. Later, its application to the behavior of light led Einstein to formulate the special theory of relativity. Update. With the fiber optic gyro with a linear segment, Galileo could not only find the ship's speed, but also the heading by rotating the fiber optic gyro with a linear segment in a horizontal plane to detect the maximum speed. The key to understanding the revision of Galilean and special relativity is the alpha theory. Summary. The dynamical Euler-Lagrange equations are derived from a classical Lagrangian model that's completely abstract. Its generalized coordinate system contains no reference to the reality of a reference system, containing an observer/detector at the origin. Such a model assumes that all real reference frames are equivalent. Frame independence. The derived laws are valid for all observers. This is the principle of general covariance as promoted by Einstein in general relativity. However, the results of the Wang fiber optic conveyor and sagnac and Newton's bucket, an old guy with his bucket, tests have pointed to only one reference frame that satisfies the Euler-Lagrange equations, the lab frame. The Lagrangian variational principle is valid/covariant if and only if the observer is in the lab frame. The conclusion is that kinematic laws are always valid for kinematic velocity, but the dynamic laws for dynamic velocity are only valid in the lab frame. Confuse the two at your own risk. And by the way, thank you, Robert, for popping in earlier just to clarify that and make sure that we remember that for the rest of our lives.
Pop out of the lab frame at your own risk. Is that what he said?
Yeah.
That's awesome.
When the Copernican model was proposed 5 centuries ago, the Occam's razor argument for its adoption was solar system simplicity with the sun at the center. But there were no decisive texts for heliocentrism based on the scientific method's testability rule. Electromagnetic theory in the 19th century demanded an ether medium for wave propagation, so Michelson-Morley tried, unsuccessfully, to detect the Earth's motion through the ether, which itself was assumed stationary, the ether. Although one obvious conclusion was that the Earth was not moving, the response of the physics community was one of desperation. To avoid the reality of the geostatic model, Einstein proposed a special theory of relativity in 1905, which had two axioms. First, that the laws of physics are valid in inertial frames. And second, that the vacuum speed of light was always constant. Relativity was an odd name for this theory indeed, as light speed was defined as absolute, not relative to anything, and the first axiom, having nil to do with relative motion, was actually a statement about covariance, the validity of dynamics in inertial frames of reference. The proper name for axiom 2 is really covariance of inertial frames, which is what Galileo stated in his ship at sea parable. Despite contradictions, in its premises and practice, the rational special theory of relativity was adopted by mainstream physics as a reply to the Michelson and Morley null result. Until the sagnac test of light speed on a rotating platform was performed in 1913. Sagnac found light speed was affected by rotation of ambient matter, disproving special theory relativity's axiom of constant speed. He also surmised that ether was not rigid, but was stirred up into a whirlpool by the spinning mass, as air does in a fan. Ether not only existed, but was flexible and pliant like a fluid. Sagnac's result was universally ignored, usually on the basis that special theory relativity does not apply to accelerating motion, even though Einstein gave several examples of the special theory relativity applications to circular motion. In 1937, Dufour and Prunier revisited the Sagnac test and found light speed in the lab frame was the same as on the rotor. Light speed equals c plus or minus v. This supported the ether drag hypothesis, so the laws of dynamics were tested and validated in the lab frame outside of the reference frame. Go ahead and belief that the Sagnac result of 1930 or 1913 only applied to rotational motion was discounted when Wang found the same results for linear motion in 2004. The Wang test analyzed above removed the objection to the Sagnac test. Special theory relativity does not apply in the rotating frame. This claim was always specious in the rotor frame. The lab rotates around the rotor, yet the lab is the one frame that has been thoroughly tested dynamically. The Sagnac result has never been credibly explained, despite its wide application in modern technology. In turn, the Wang paper has been virtually ignored in the last 10 years, but remedied by this paper, which establishes the test as a critical sentinel of striking new concepts. Kinematic and dynamic motions were carefully distinguished, and the neglected topic of covariance was reviewed and applied to the Galilean dynamical law of velocity addition. Analysis of Wang's result in the conveyor and lab frames with the premise of ether drag logically leads to identification of preferred motion in an absolute frame of reference, the earthbound laboratory frame. Relativists often challenge dissidents and to offer a credible theory to replace special theory of relativity. That light speed in the lab frame will be the same as for the conveyor is a testable prediction of this paper and the alpha model. We predict the same test result as the Dufour-Prunier test. The profound conclusion for light speed in a lab frame being c plus v, where velocity is vn lab, was that the lab frame is the absolute frame of reference for all laws in dynamics. After all, light speed should be c, not c plus or minus v in the non-lab frame, since conveyor and ether move together. The alpha theory summarizes this conclusion with 1. Absolute lab frame, and 2. Flexible ether co-entrained by the moving matter. Discovery of the absolute lab reference frame and a flexible ether, the alpha model, refutes relativity and its alleged consequences, such as both postulates of special relativity, general covariance and general relativity, Lorentz transformations, Minkowski space, length contraction, time dilation, all linchpins of relativity, disproven by alpha theory via the Sagnac and Wang tests. It turns out relativity was misstated from the very beginning. There is a law of relative motion, that applies only to kinematics, to the relative motion of two reference frames, not one, and makes no prediction about future motion. There is no law of relativity in dynamics, only the law of absolute lab frame covariance. If one were allowed to distort the real measurements of space and time with Lorentz transformations, then one could force light speed to be the same for all observers. But physicists with common sense belief and philosophical realism reject the distortion of sense.
Almost done.
No, this is great. Like, this got good, man. Sense images in this way. To a realist, space is what a ruler measures. Time is what a clock ticks away. Such is the valid testimony of the senses. Reflection on the last century in physics leads one to wonder how such self-defined, intelligent modern scientists could wander so far astray, as do drivers in an unfamiliar country whose male ego refuses to admit they made a wrong turn, or to permit retreat to the point of the errant turn. The counter evidence to relativity was the Michelson-Morley test itself, with the static Earth interpretation as evident as the emperor with no clothes or an elephant in the living room. Evidence afterwards includes the experiments of Sagnac, Dufour and Prunier, Ruyong Wang, plus all the light anisotropy results when done in a non-vacuum. Could there be, in the establishment's rejection of geocentrism, hint of a struggle transcending mere science? Or confusion born by delusion, not just ignorance, a battle that deals with the highest level of human concerns, truth versus lies, life versus death. Once to every man and nation comes the moment to decide, in the strife of truth with falsehood, for the good or evil side. Some great cause, God's new Messiah, offering each the bloom or blight, parts the goats upon the left hand, and the sheep upon the right. And the choice goes by forever, twixt that darkness and the light, and that light. Though the cause of evil prosper, yet 'tis truth alone is strong. And albeit she wander outcast now, I see around her throng, troops of beautiful tall angels to enshield her from all wrong. Careless seems the great avenger, history's pages but record. One death grapple in the darkness twixt old systems of the word. Truth forever on the scaffold, wrong forever on the throne, yet that scaffold always sways the future, and behind the dim unknown standeth God within the shadow, keeping watch above his own. 'Tis as easy to be heroes as to sit the idle slaves of a legendary virtue carved upon our fathers' graves. New occasions teach new duties. Time makes ancient good uncouth. They must upward still and onward, who would keep abreast of truth. J.R. Lowell.
Shout out to J.R. Lowell. Awesome, man. Great read. Thanks for picking up the last 18 pages, dog.
Dude, I got into that last page and a half or so.
I can tell,
Like,
dude.
Dude, he took the gloves off, man. He was getting I don't know, that was good writing. I liked that a lot.
Yeah, good stuff. I'm beat, dude. After
Yeah,
after today,
we're
dog.
not doing appendix, man.
Yeah, I'm not doing GPS after this either. We're calling it a day. We'll come back to it another day.
We've been going for 3.5 hours.
Just
Shane wasn't here to tell us we've gone too long.
Dude, yeah, without Shane, we do a 3-hour episode. Classic, dude. All right, yeah.
Hey, you guys, wait a minute before you go. I didn't get to participate. I was just.
No, yeah, dude. That's what I was gonna say. Let's just open the floor for a minute.
Yeah.
Yeah. Would you say that way that this all really kind of works with these reference frames is kind of like the Goldilocks effect? In a way, it's like everything just so happens to be perfect in synchronicity in these two different frames at the same time. Would you compare it to that possibly?
No.
Coincidental?
I mean, I would only compare that to that if you're gonna claim the Lorentz transform. It's you're gonna say the reality is the Lorentz transform, but our reference frame happens to be in the Goldilocks zone where we actually just see what makes sense.
That's what I'm talking about. That's what I meant. Exactly that, because I heard you talking about the Lorentz transform, the coincidental part of it. That just so happens to be this way.
The thing is, like for me, when I saw the Lorentz transform being applied just to a local sagnac effect from like a gyro,
You were like,
like
what the hell is happening right now?
yeah, once you see that, it's like no, it's not like like yeah, that's I guess that is what they would say is that we're in some kind of like Goldilocks zone or something, but it's like nah, dude, it's just like it's worse than that. Like it's just all ad hoc BS.
Completely. And so is the Goldilocks zone in any way. Like I often say that like everything's kind of like that in a way, like with the globe model.
Yeah.
Like it just so happens to be this big, or just so happens to be so large that you can't see the curvature, and everything's just so, or it just so happens to be this far away from you know the horizon that it looks like it's flat, blah blah blah. But that I always say to, or not always, but I came up with this phrasing of it, is that the Goldilocks zone makes you sound like a dumb blonde, right? Because when you're going along with that for the glow model, it's like you sound like a dumb
Yo,
blonde. Like this is the
yo,
way it works
before
out. But then I was thinking that the Ken. This is where I was going with it. We could call it the Ken and Barbie effect, right? Because it's the kinematic like Goldilocks zone type effect. I don't know if that works or
yeah,
not, but you know what I'm
yeah,
saying? Like Ken and Barbie.
yeah, we're reading the appendix.
Oh, is it
All right.
good?
Yeah. So, appendix: contrary opinions of Wang's fiber optic conveyor test. Claim 1: What what explains the Wang results is light moves along the closed circuit and the observer is in motion with respect to that circuit. Reply: This is what the Wang test shows. 1. An object moving in the lab frame drags along an ether with the same speed. 2. Only the lab frame can be used to apply the laws of dynamics. Claim 2. The equation delta T equals 2VL over C squared is based on the constant speed of light. Reply: The measured speed of light was C plus or minus V, not C. Shout out to Chris, dude.
Right.
The,
Chris.
claim 3. The Wang experimental results agree exactly with the prediction of special relativity. Oh, we've heard that one before. Reply: The principle of the constancy of the speed of light is everywhere, so the speed of light equals c. This is refuted. This is refuted by the results of the speed of light on the conveyors, the speed of light plus or minus v, where where v is the speed of the conveyor and the entrained ether. 4. Or claim 4: The reflected light will be redshifted from one mirror and blue shifted from the other mirror depending on the state of motion from the source or receiver relative to the fiber optic cable. Reply: There is no relative motion between the emitter and the receiver, and the fiber cable is measured in the conveyor frame. Everything else is at rest to that frame. 5. Or claim 5: The optical path lengths are different in the conveyor and lab frames. Oh, where we hear that at, Toby? Let's see. Reply: The speed of light is results in both frames is equal to the phase shift in time, or equal to the optical paths traveled by the light in both frames are equal.
Thank you, Robert.
The speed of light results in both frames are equal to the phase shift in time, are equal to the optical paths traveled by the light in both frames are equal. Claim 6. Dr. Wang linearly moved a straight section of the fiber while the rest of the device he held was stationary. Oh my god. It's like, dude, it's like he talked to a bunch of people that already thing. We should have just read this. We could have saved 2.5 hours, dude.
Right.
Man.
I'm glad you decided to read this.
Claims.
Dude. This is
Yeah.
Oh,
Seriously.
this is literally the summary of earlier
conversation earlier.
Claim 6.
Yep.
Claim number 6. Dr. Wang linearly moved a straight section of the fiber while at rest to the device he held was stationary. Reply: The source detector of the fiber optic cable moved together with the lab frame. The sagnac detector of the minus the fiber optic gyro. Am I reading this correctly? Are these minus?
Source detector and fiber optic
fiber
cable all move together in the lab frame. The sagnac detector minus the fiber optic gyro. Oh, the sagnac detector, the FOG, reads speed of light equals c. when translating and not when translating and not rotating in the lab frame. That makes sense. The whole
Alright.
interferometer is in linear motion in the lab frame, but only the linear segment produces the phase shifts because of the linear motion through the ether.
Yeah, no way. Are you sure there's not like an additional distance variable from a hypothetical reference frame relative to an absolute space that you're invoking from a third perspective? All right, dude. Cool. Claim 7. It has not been demonstrated that linear motion of the entire device can register a signal. Reply: in fact, the graphic results say exactly so. When the conveyor moves in the lab frame, the phase shift is registered. Dude, it's like so. Dude. Claim 8.
Yeah,
The
this
phase
is
shift
really-
occurs due to the time of velocity change. Reply. Okay. Claim: the phase shift occurs due to and at the time of velocity change. Reply.
we heard that one.
Reply: the shift is constant at constant speed as the graph of the shift versus the speed shows. The cause of the phase shift is the velocity, not the velocity change, i.e. acceleration. Wow. Cool. Claim 6. We have proved that the Wang effect originates from the closure of two space paths as seen in a frame co-moving with an emitter / receiver, and from relative motion between the emitter receiver and the fiber optic or optical fiber or physical device. Reply: the co-moving frame in the co-moving frame, everything is at rest except the light beam and the surrounding laboratory. The beam paths are always closed. There is no relative motion between the emitter / receiver and the optical cable. Everything is at rest. Why is this concept so difficult? Can relate, brother. Can relate.
Feeling that one, buddy.
Yeah. Awesome, man.
Especially for that one, because that literally is the same one where we were just like, why is he talking about that? That's funny. Why is this? That's really funny. Well,
That
cool,
is,
dude. I'm glad
yeah.
we went through that too.
Yeah, that was great to go through all the claims right there at the end. That was just the perfect way to close it out. Because I mean, you can predict what bullshit they're gonna come up with, or what excuses they'll put forward to debunk or attempt to debunk what's plainly written in front of them. But yeah, man, that's
Yeah. Oh, I forgot. Daryl Frost.
shout out to
wanted-
Bennett, man.
Yeah, there was a question in the comments. Can you define covariance, please? So here's a really good example I'll bring up from Bennett's thing. But basically, mathematically speaking, they look at covariance pool right here. So covariance, reference frame effects on physical laws. So when you define the physical laws in mathematics and you transform to a new reference frame, they're basically saying that mathematically speaking, if the laws change under the transformation, that means you're not doing things right. You're not in line with nature. You're not creating a valid structure to analyze reality. So they have this covariant system, and that's what they reference everything through with the math framework. So it's like, was the example given? So it would be like, okay, so for example, for covariance, is the Earth moving around a satellite, or is the satellite moving around the Earth? Well, you can analyze the motion kinematically, but dynamically, the only covariant situation there is going to be the satellite moving around the Earth, right?
Nice.
Yeah. So that would be a covariant relationship with motion, right? And then when you do it they do it with other stuff too, like primarily C, right? So when they transform stuff, usually where the speed of light changes, what they're invoking a Lorentz transformation for is to make the speed of light C, and they say that successful transformation is covariant. So they're like, oh, okay, cool, we're safe. Like we can we can invoke a different reference frame to analyze the constancy of C and then utilize it in reality as a it gets convoluted as hell. But this is supposed to be like their rule book for their mathematic framework when describing reality with mathematics. All right, cool. Sorry, I just wanted to get that question out because it's a good, important question.
Mm-hmm.
All right.
Yeah. Anyone else? Anyone else want to say anything? Ask anything? We could close the stream up here if not.
I would like to say that I really appreciated the poetry at the end there too. I'm a sucker for well written poetry. I really, especially as it relates to this topic. That was
Right. Agreed,
that
man.
was
It's
good
like
stuff.
if it had been any other subject matter, it's like I might have skipped it, but it's like, dude, we're reading Bennett. Bennett put this here. We're gonna read this for sure.
Yeah, because he put his heart into it is the thing.
Yeah.
And like if you try to put yourself in Bennett's shoes, that's why I give so much like credit and respect to people like him, you know, that are in his shoes where it's like I don't care it when on, you know, if it was during his career, after his career, whatever, he's got a whole community of peers in his life where just coming out and saying what he said like that's a monumental decision for him, you know what I mean? He's going against the grain in so many ways and people they get ostracized for doing that, for standing up for what they believe in and speaking truth. So it's funny as you were reading that section in the poetry, man, I just kind of picture him really pouring his heart and soul into his work. And, you know, and that's kind of like a little bit of artistry that he added at the end there, that's just really cool, man. It's touching.
Agreed.
What's great about it is when you do something like that, only in hopes that people like us might pick up on it and make a live stream and make a big deal about the little thing you did that nobody wanted.
Yeah,
Yeah, it's kinda awesome.
dude, he's influencing hearts and minds, man.
Yeah,
It's all about.
Yeah,
he's a celebrity. Now he's
he's
getting his comeuppance.
his lectures to us, the things he's taught us, the stuff he's talked to us about, and then his papers, man. Like the dude has given us like a scaffolding of real concrete science that we can work from. Like, thank goodness.
A really,
Right.
yeah,
No,
a
I
really
am so
good
thankful
framework
for
to
that.
interpret things from, you know,
Absolutely.
like giving us that fundamental basis. Because like if you don't go through that training pipeline, you know, you're not going to hear about kinematics and dynamics and like right, like Dave's been talking about that forever, and like nobody, like you know, few
Right.
people pick up on it, and like, but like once you do, it's like there's the separation, right? Like there's where they've tricked everyone.
Yep. And
Yeah, and
Brenner
it's
falls right into that category. He's been quietly just saying these exact things on this long.
Yep.
Probably is enamored that we even pay attention to what he's writing. I mean, it's amazing.
Yeah, and it's until like we all I feel like Bennett's work kind of gives us the words to express what's on the tip of our tongues, but we're not, you know what I mean? Like it's the
Yeah.
kinematics versus dynamics portion of it, you know, covariance and all like these are the terms that we should have been using all along had we had those resources to kind of educate us on how to properly address these issues. Because it's so obvious that that's the case. Then when you actually use the proper terms and lay it out that way, you know, of course we could all go back to the foundational premises of okay, well we know for many reasons that Earth is stationary. We can assess it in this way or that way, but in order to argue um, on the high level stage, you know, with people that are used to using these terms, it helps so much to be able to have a resource like Bennett who can come in and be like, this is actually what the proper terminology is. And kinematics and dynamics is the issue because relativity, that's one thing that was a kind of a light bulb moment in my own paradigm when I realized, oh yeah, kinematics relativity is true kinematically, so like that is kind of the where the issue resides in is that they're
Yeah,
trying to claim a dynamic equivalence as well, and that's where you fall short of reality. That's where you're contradicting
exactly.
what's empirical right there. You all day long you can make the kinematic equivalence assertion. That's okay. And like at least from my perspective, like when I'm watching like, you know, when I'm arguing from a geocentric position, it just helps so much to organize my own thoughts to view it that way. Like, hey, we can make observations and place Earth at the center. Hell, we can make observations and place any of the celestial bodies at the center and kinematically make it work out.
Dude.
But you know what I mean? Like when you want to go into dynamics, well, that's a whole different ballgame. Now you're talking about what's real, you know?
You know
What
what's
can
Hey,
you
is this Chris
prove in
Porter, by
reality?
the way? Is this Chris?
yeah.
This is Chris. Yeah, I'm your neighbor, bro. That's
Dude, yeah, dude. Chris and I just figured out when we were talking to Jaron the other, a couple nights ago, we live like 5 minutes from each other.
Oh no way, that's awesome.
Yeah, totally.
yeah. We're like, we're hanging out at the VIP after show, and like, yeah, it just comes up, and yeah, it turns out we're literally we're like down the street from each other. So
Yep.
Dude,
nice
that's
little
awesome.
synchronicity there.
Awesome. Hey, were you the one saying that like if 2 + 2 equaled 0.25, then mathematics would be, you know, have a big problem, like with the whole like kinematics versus dynamic thing? Like that's like saying 2 + 2 equals 4.156 or something like that. Just doesn't make any sense. But with kinematically, you can do those kind of like, you know, estimations, and it's okay.
So in a couple, I forget which presentation it was, but Bennett was on he was doing a presentation, and I did tell him, I didn't say that specifically, but I did tell him he used a cartoon or a comic, political cartoon in one of his slides, which really hit home for me, which was there was a bunch of protesters saying 2 + 2 = 4 in a world of 2 + 2 = 5, and
Right,
like
right.
that like really speaks to where we are right now in this world, is that like we're sitting here going, hey, like, and it perfectly relates to Newton's bucket, because Newton's bucket is something that on the face of it should be obvious and just a given that is easy to accept for anybody. You know what I mean? But like we're in a world now where everything is we're being told that everything is relative, not just in physics, morality, and everything has got to be relative. Oh, there it is,
Right.
Alan. Yep, perfect. Yep. So it's like, it's like 2 times, 2 times 2 = 4, and it's like there, and it's like man, dude, that pretty much sums it up. That's our plight right there. Is like we're
Yeah.
holding that banner going, hey, remember guys, remember when we just took what was empirically substantiated, what is true in reality, what we can know, and we're holding that sign up going like, dude, this is what's true. And we're in a world where people are freaking out when they hear that, because everywhere around them they're being told, no, forget all that bullshit. Forget all that. It's 2 times 2 = 5. It's that way. Everybody thinks
From that
that.
reference frame, it totally does.
Yeah. Yeah.
Yeah,
So
that's a good little cut. That what you just that little rant that you had on that, and it reminds me of last week, Shane's little rant about moral relativity and all that. Did you cut that out, Toby? Remember that when he went on that long like
Yeah. I haven't cut that out yet, but I know
but that
exactly what you're
you know
talking
what
about.
yeah, get that if you can, because that was the little Shane to tie it all up. Just like we've all kind of made that point, but it was Shane finesse on the whole moral relativity and reference frame dependent society that we've created.
yeah, and that's not a coincidence either.
No.
You know what I mean? It's not like we're just drawing parallel. Oh, that's interesting that simultaneously happened. You know what I mean? When you like, that is really what's behind everything, is this. They're trying to take us from what we can show to be true, what we know to be true, what's objectively true, to a subjectively relative viewpoint where, oh no, any reference frame you're in is just as valid as any other, because there is no objective reference frame, just like there's no objective truth. Like, you look out into the universe, you look out into the cosmic, what we see, and you go, oh, everything appears to be moving away from us. No, that's not true. You're just relatively, like, if you were anywhere in the universe, you'd see that exact same thing. It's like,
Yeah.
oh, well, we try to measure our motion we're supposedly in motion, right? Well, it shows we're stationary. Oh, no, that's not true. No matter what reference, no matter where you are, that's what you would measure. You know what I mean?
Yeah.
And no matter what, like you say, where you go, this is proven to be the case. This is objectively true. We can empirically substantiate this claim. They'll come back and tell you, no, that's just your subjective viewpoint. And if you go anywhere, any other viewpoint is just as substantive, even though they can't empirically substantiate it. So I think it's
Right.
morally, I got really I hope you do clip that out so I could, or maybe what episode was that in? Because I missed that.
Toby's gonna get it. He'll make a short of it.
Hell yeah, man! Because I love that is the point, man, and that's why I think, as most people have figured out, that's a big reason, if not the reason, why this lie is perpetuated. Is to confuse people into that moral relativistic viewpoint.
Yep, it's Wizardry 101. It's like the thing you learn wizard will like to say. They're like, okay, here's how we do it. Everything's relative, so we can create anything out of anything.
Yep.
Yeah,
Exactly.
amen, man.
Exactly. Well, I'm like kind of beat. I would like to maybe end the stream if everyone's down, unless anyone has any other final thoughts. Definitely can open the floor one last time for any last comments.
Any more kinematic concepts? Anyone want?
Hey, I just want to say thank you guys. I just want to thank you guys for putting this on and letting us try to absorb the information. I mean, we're not all physicists or engineers, but we're trying to learn and
Right.
appreciate your patience and your willingness to let me be the dumbest guy in the room. So thanks, guys.
We've all got to be that guy at some point.
Yep.
Yeah.
Hey,
Yeah, and I
Alan,
will
are you
say
still
this.
here? I was gonna say, go ahead. Say this first.
I will say this, silly questions. If you're feeling that way, don't think that anybody on their first read through that paper understood everything written in there. Like, that's crazy. You know what I mean? Like, there is no way on a single read that you would able to be able to absorb and comprehend everything you just read in there. I mean, it took Bennett God knows how many decades to come up with that, and to be able to put it into words that's digestible and understandable to begin with. And Alan and Toby can probably tell you how many hours have they spent poring over one paper over and over again just to go at it a 20th 25th time and then pick up something that you didn't realize before, because that's happened to me so many times.
Or
Happens.
just coming to these ether cosmologies, and it's like Alan and Shane are going back and forth, and I'm just like, oh man, I'm like way behind.
Yeah, geodetic surveying, dude. When Shane, I had been studying geodetics. I had listened to Witz's debates. I had thought I got it. I thought I had it on lock. And then, I watched one video of Shane talking to an actual career geodetic surveyor, and then something clicked in my mind where I realized that for like a year now, I had thought I understood a concept, and really it had gone over my head. It was giving me a haircut this whole time until Shane was able to put it in terms that I truly understood. So whenever you're like approaching a topic, you're like, damn, I feel dumb or whatever, just realize like it takes a while, man. It is just like anything, man. It's like any skill that takes a while to master, or even to gain like a good understanding of. You just gotta keep on hitting the material and keep on going at it, and eventually things will start falling into place and the pieces will start fitting.
Yeah. On that note, I didn't listen to all of it. I'm back and rewatch some of it. But I was gonna ask Alan or anybody if there's a way of correlating directly you're saying with the conveyor belt and the absolute reference frame. I'm sure there is, of course, but would there be a way of wording it in the way with the plane argument? Because it's exactly the same thing, right? The plane is only flying in reference to an absolute stationary Earth in the same way that this whole thing's working, right?
Yeah,
So that's
yeah,
like a
you
more
summed it up
real
really
world
well
example.
last time. Yeah. Or yeah, if you want to run through that argument real quick. And we'll close
Well,
out
yeah,
on
it's just
that.
that yeah, the plane has to land on a stationary Earth. If, if they're treating it as stationary, way to treat it as stationary if it's actually moving, and it's the like real world example that we're just saying silly questions. You know, to understand it might be a little harder. It's not. It's just like it's as simple as that. If the pilot's trying to land on a runway that has a different tangential velocity where he started off from, can't claim that the conserved momentum from where he started off from is going to somehow make him in that same reference frame completely in sync enough to treat the runway, which could be at any whichever angle, yeah, as if it's just stationary. There's just no way around it. Kind of what this whole thing is showing in a more specific, technical way with the light and everything else. So it's really that simple.
Yeah,
Cannot
super
do
well
it.
said, Dave. Yeah, no, and I'm not I didn't mean to like I look, I what I'm trying to get at, guys, I'm not trying to like, it's not like a put down to myself. What I'm trying to say is I'm super happy to be in a room with a bunch of smarter people, like, and to find this place and that you guys do this work here, like it's a privilege, and I'm really thankful for you guys. That's what I'm getting at. You never
Nobody's
want
smarter than you, man. We're all just trying to figure this out because we've been scale that it's like, wait a minute. Oh wait, oh they forgot to include common sense in all this. Oh, okay.
Yeah, bro. Well, like, I'm not smarter than you. I've just read that paper 23 more times than you, bro.
Right. But
It
seriously,
is
like,
just common sense.
but I do love hearing that because that's the whole point of this place, man, is for us to come and we can get into the super high, like, we have the debate spaces where we're talking to people that disagree with us, and it's not that I don't want this to be a debate space. I'm open to it, but like that's exactly my main goal for this place is like somewhere where we can come and we can get into real science like together, and we can all like, we can get into high level stuff, but if someone has questions and they need to bring it down to a different level and make sure that we all understand things accurately, then like, yeah, that's perfect. That's exactly what I want this place to be. So heck yeah.
Yeah,
Yeah, well,
And
thank you, Toby, for helping to make it that kind of place, man. Because that's just another another name. You're another one of those names in my Rolodex now, where I'm like, bro. And I would hit up Alan all the time with like, I'd be like, hey, dude, this guy's telling me this about the cosmic. What do you think about this, man? And like, he'll give me some gravy on that, And it's like that's so important because I feel like a lot of people have slices of the pie. But when we all
Yeah.
come together in a space like this, we get all those together, and yeah, no,
Well, dude, it was so cool to like one thing that's awesome about this is like spending all that time getting into interferometry, doing my research, learning from different places, different people, different books, different papers. And then you show up like a week or two ago and you like break it all down with the history and everything and like actually understanding the like meaningfulness of all of it. And it's just like, dude, this dude I've never talked to before like knows it. He gets it all. It's just like so nice to know that uh you're not like alone, we're not just coming to these conclusions on our own, but like other people in other parts of the world are seeing the same pattern. Yeah, it's cool.
yeah, the feeling's totally mutual, my friend.
yeah, I was gonna say on that note, sense thing, like I've said since first hit me that like, oh wait a minute, common sense. Oh, what? Why is this? Why is the consensus have no common sense involved? Like this is a war between common sense and consensus, which would be a great title for a book, by the way. And then when I noted that when I emailed Brenner for the first time, he said, "I like your phrasing of this is a war between common sense and consensus. I'm going to use it in my further writings." That's like the biggest honor ever, someone that
Yeah,
uh,
that's awesome.
I'm like putting on a pedestal is going to use my wording on it. That's basically what it is. It's nothing brilliant. It's just a simple fact that they took common sense out of the
Well, they got us.
Yeah,
They
he's not
got us
the only
all to
one that's
lie to
stealing that,
ourselves.
bro. I'm stealing that too. That's good.
right.
They took common
Has a
sense
good
out of
ring to it.
consensus. That's great, dude.
Yeah.
they
Well,
replace
dang.
common sense with consensus. Like it's just
Right.
insanity.
They took common
That's
sense.
Yeah,
and
they
made
tell you
consensus.
that
Common sense is consensus, right? Yeah, exactly. Appeal to authority, appeal to majority, and that really is what all this is built on, right? It's appeal to authority and appeal to Yeah, they tell
majority.
you that
Anybody who wants to know why Einstein is like promoted as a celebrity in the first place should go back and listen to Alan's earlier videos about how Einstein came to rise, because that's very illuminating. You know, how he just became this overnight celebrity. It was the people who are in control in this realm who propped him up as an idol for the people, for the masses to look up to for answers. It didn't happen organically. You know what I mean? It was a manufactured appeal to authority is what it was.
Yeah.
Yeah. And then appeal to people, anti fears and all that too, on top of that, like using him just like they've used the cripple in the chair and all these other things. Oh, you can't attack this guy because he's Jewish or because he's in a wheelchair, because he's got Asperger's syndrome now, you know, or whatever it is.
Yeah,
Isn't it Asperger's? Isn't that what Musk has?
something like that.
Oh,
No, he has pretend. He uses that as a crutch because he's a bad actor and not really smart.
that
It's
probably is
it's an
pretend too.
insult to people that have Asperger's to say that
Yeah,
guy's got it based off of his behavior. Which, anyway,
it's
um,
perfect though. It's the perfect excuse for being so dumb and
yeah, if you've never been around someone with Asperger's, it's great. It's a great crutch. It's a great crutch. All right, so I think we're gonna end out on that. Thanks for coming out, everyone. I'm gonna shut down my stream. Peace, y'all.